So Sharon Nee, I would love to thank you for joining us, product designer at Cisco.
Cool. All right. Hi, everyone. I'm Sharon. Super excited to be here and share with you some of the AI stuff I've been working on. I'm a product designer at Cisco's security design team, and I'm currently working on Cisco's very first AI initiative called Cisco AI Assistant for Security. I have a background in psychology and linguistics, so I focus more on the language and also content side of things, like information architecture, conversation design, and prompt engineering. This is also my first time in a while getting up on stage to speak. I've been mostly online, so thanks, Steve, for having me. I also had a great time judging and seeing all those cool projects yesterday. So next slide, please. Oh, like this?
It'll pick up less.
Okay, great. How about this? Okay. So when Cisco decided last year to jump on the AI Fright earlier last year, I was part of the small landing party of folks tasked with figuring out how to build our very first AI-powered features for our security products, such as Splunk, Secure Access, and Dual Security. Our customers, they have very high expectations that Cisco will deliver differentiated experiences using Gen AI to improve their experience and also consolidate knowledge and insights across Cisco products. And the purpose of why I'm here today is to explain to you not only what Cisco AI Assistant is, but also how we design it from a user experience perspective. As I said earlier, with this AI Assistant, our goal is to bring several key AI products together from security and networking and combining all of them into one place using generative AI and machine learning, and also allow our customers the ability to accomplish key tasks, simplifying their overall workflow. We also wanted to make sure that we meet users where they are and provided contextual experiences across a wider variety of contexts. Our users are mostly security experts or IT admins. Some of them are very technical and some of them are not. Next slide. Just to give you an idea of where we are right now, we are still very much using AI as an assistant or advisor to support human, not trying to replace our IT admins or trying to make the decisions for them. I'm going to explain why just in a little bit. I think this is important to mention, especially for those who work in highly regulated industries like security, financial sectors. We wanted to make sure that we're designing the experience, we're designing a very trustworthy experience for our customers from day one, and we're not using AI for the sake of AI. Thanks. Next slide. But AI is not a silver bullet, and we have some very special considerations when it comes to designing an AI assistant. For example, generative AI sometimes can be very inaccurate and can make mistakes, and also it can be very inconsistent. There is also a lot of privacy and security issues involved when using it across multiple products and also platforms. Most importantly, most of the responses generated by Gen AI, like ChatGPT here, are like a wall of text. They're very hard to read and also very hard to find useful information. Next slide. And also, we did some research with our customers. We're trying to identify some of the existing product issues, just trying to make sure that we're not building AI for the sake of AI. We're always trying to solve the real user problems and real user issues. So we've seen there is a growing cyber attacks around the world. About 90% of the organizations right now, they're experiencing at least one data breach or cyber attacks just in last year, 2023. And also for those companies, they don't have enough security experts or IT admins to support those incidents. And people don't really understand the value of our products, and teams often forget to revisit their security settings. And also for those security experts or IT admins, not all admins are security experts. And some of them just lack the experience to handle all those threats that they're facing today. And even for those very experienced IT admins, they sometimes also don't want it to see those very technical concepts or jargons. They just want it to have a very simple and efficient experience. Next slide. So here are our priority use cases for this AI assistant. For report summary, it's basically to create a summarization of the user activities or summary of the incidents or effective policy using the template and examples that we injected into the model to help the AI learn how to write a formatted, concise, and readable summary. And for troubleshooting and threat detections, we're leveraging the power of LLM to find patterns from previous activities and those help center articles and instructions or from documentations and also from customer support history, so the AI can also answer some of the product specific questions. They can also ask questions and pull data from our products that's connected to this AI assistant. So the master LLM will be able to have the base knowledge of all the products. So they can also ask questions related to any security questions. Next slide. So we also demoed this to our customers during the Cisco Live earlier this year, and we received very positive feedback from our customers. But we also got some feedback like the text on the trigger button, like this one, the view incident, is not very clear. They don't know what's going to happen after clicking on this. And something more contextual would be better, like a question format, because they also they also have to switch back and forth between this AI assistant and our product, and sometimes some other internal communication or ticketing tools like Jira or Slack. Next slide. So this is our main chat interface look like. Next slide. So some of the lessons I learned from working on this project was that first is that we needed to build a cohesive pattern so that our users can build a clear mental model of the product or the AI assistant. And having that clear mental model will help improve usability. There are different ways to do it, like to share our terminologies, design guidelines, and repositories with our partners early on, including those that we work very closely with, like our engineers, data scientists, and also marketing teams. Secondly, we also have to make sure that every users of our product can understand how to use this AI feature by providing step-by-step guidance throughout the onboarding journey and also contextual recommendations and follow-up questions, so they don't have to type in the questions in the chat themselves. And next is to really think about mobile-first content for the chat interface, especially if you're building a chatbot for desktop or on a web. Definitely think about the screen size, and if you wanted to make sure that your users stay longer in the chatbot, or if you want them to go back and forth interacting with the product itself. Also, think about information hierarchy. How much information is enough information in a response? Think early about content, especially structured content. Our Tech Docs team is also leading another initiative to develop a tool to help us clean up the documentation so that the LLM will be able to read and use it directly from the documentation. Also, I think it's important for everyone who's involved in AI to learn about conversation design. Those conversations between our users and AI will bring us huge value. It will help us understand our users in a much, much deeper way going forward. It's not just about how many times they click on a button or a link. You'll learn so much about their behaviors through the way they talk and the words they use. so that we can create personalized experience and even sales strategies that fits right into their needs. And for our security products, we're using conversational AI to help our users build a more accessible and frictionless experience. So everyone will be able to understand those technical aspects of our products and be able to ask questions in natural language. Yeah, so that's all I wanted to share today. Thank you so much.
So real quick, I'm Brian Wong. I'm a partner with Moss Adams. I'm actually joined here by my colleague, Brittany. We're focused on our technology clients here in the Bay Area, and the both of us are actually getting more and more involved in the AI space. So we really appreciate being here and looking forward to hearing a number of you guys speak today to learn more about the AI space. So just a little bit of background about Moss Adams and why we're even here and how we can potentially help. So Moss Adams, we're a full-service CPA firm. Yes. And so we actually work with companies of all sizes, whether you're an early-stage startup or you're publicly traded. For our early-stage startup clients, we can do everything essentially from an accounting perspective. So we actually help a number of our startup companies do everything from their bookkeeping to payroll to accounting software implementation. We also do a lot around tax compliance and tax planning. For a number of our early stage startups, we actually help them monetize for the first time their government credits and incentives. We also work with a number of their founders and executives around their compliance and tax planning so that they can plan for future tax gains and what they should be doing today. And then as your companies grow and evolve, we continue to work with you. So as you commercialize, as you expand your presence to other states and internationally, we stay involved. And then finally, as companies go through M&A deals, or you go public or are operating as a public company, we can continue to work with you. At that stage, usually later, we also have wealth management services, so we work with a number of founders and executives in that instance too. That's just to say, if you do work with us, we work with you along every single stage of the way, so you don't have to be changing your CPA providers at different milestones. Moss Adams, we're actually the 5th largest firm here in California. We have a team of almost 5,000 across the United States, and we have the capabilities to work with companies that have presence in 120 different countries. So again, thank you so much for having us here. If you guys want to chat with us just to hear more about CPA services or not, you can either chat with myself or Brittany, who's over there. Brittany, can you just quickly stand? Maybe, yeah. We'll be over there at the Moss Adams table, so please feel free to reach out. I did have a link somewhere to my LinkedIn, but yeah, if you guys ever want to connect, please feel free. And thank you so much for your time. Looking forward to hearing from you guys speak today.
What's up, everybody? Yeah. What's going on? And I just want to say thank you guys for taking the start of your week on this Monday. You guys could be at work or somewhere else, right? But you're here, so I appreciate that. So I'm from Prem.ai, and you're going to learn a little bit about us, but mostly about the power of small language models and how a compact design can make such a big impact at your organizations with smaller models. Right? So nowadays, language models are driving this technological revolution that we're going through, as we all know, right? And they're leading some significant improvements, but it comes with a cost. And there's got to be a way for us to lower that cost, in a sense. And that's where the small language models come in. And given how effective that they do overcome some challenges. And in this talk, I'll explain what they're improving, what challenges we do have with small language models, and the experience that my team has actually building our own small language models as well. So that next one. So I already pretty much talked about this part, but yeah, next one. So the evolution of language models, it sparks the question, can smaller models with significantly less parametric memory emulate an emergent ability that larger models have? Larger models have been shown to exhibit a range of emergent abilities like summarization, arithmetic, translation, and common sense reasoning. But we're continuing to scale up in size, and our training is a lot more diverse, and there's larger amounts of data. But the abilities that are suggested here are not only just from models learning about surface patterns and language, but also acquiring a degree of semantic and logical understanding. Although there's a lot of breakthroughs in research with CNNs and attention mechanisms, there's one concept that we all talk about on a day-to-day, and that's scale. So when we're increasing data and model sizes and all these different advancements, it's taking up a lot more computational resources and can also hinder performance. So the notion that bigger is better is not always the greatest thing. Smaller models rely on pre-existing knowledge, like semantic priors, and are gained through pre-training. And even when the examples that contradict the knowledge, it in contrast can overcome this pre-existing knowledge, and I'll talk more about some of these examples here. So what problems can smaller language models solve? Small language models are excellent choice for scenarios where internet connectivity is limited or unavailable. They can be deployed directly on devices like your phones, tablets, automobiles, or also on-premise servers as well that enable local inference without having to rely on cloud-based services, which is huge. It can help you a lot with your costs, and you can keep things a lot more private than they actually are now. Next slide. So another example of what small language models can solve is that, when we're talking about situations where you need near instant responses that are crucial and you need AI to have some type of real-time conversational services or fast-paced decision-making, smaller language models can do that, especially with the reduced latency. Next. So for organizations that are going through budget restraints and also trying to figure out their costs, small language models are extremely cost effective in comparison to their larger counterparts. And the smaller size just lowers your computational requirements, reducing the need for expensive hardware and also for expensive cloud services that you may have to use. So, during the development phase, again, smaller language models are the best friend for testing phase as well. They can be easily integrated into resource constraints development environments, such as local machines or lower power servers. And this allows for you to quickly iterate, right, and test on your applications, and you can continuously fine-tune your smaller models with a fraction of the cost. Next. Now that large language models offer impressive out-of-the-box performance, and we're continuing to see how open source models are starting to prove this, right? They may not always be the best fit for every specific task that you have, and sometimes having too much general knowledge is not good enough for certain businesses. Fine-tuning small language models on domain-specific data can yield superior results, right, compared to generic LLMs. So by focusing on narrowing the task, some great performance in the benchmarks, and we continue to push out more small language models as well. So just to roughly talk about some of the results here, the Tiny Llama models appear to be top performers overall. And if you continue to go down the slides here, it's really, really technical. But I would just say that, part of what we've seen here in these benchmarks is that we do have some places to improve. However, on our platform, you're able to actually test and experiment with a bunch of different models, small, large, and also open source or closed source as well with the entire Prem SDK. So if you have any questions, come and check me out. Learn more about what we're doing with small models and how we can apply it to what you're doing within your enterprise and whatever project that you're working on. So thank you.
Thanks, Joshua. Stay right there. We'll pass the mic if anybody has questions. And if you have questions for Sharon, who went first, please see her. I apologize for not running the mic for the previous presentation. Does anybody have any questions?
I am Nico from Prism Eval. So we are an AI safety and robustness evaluation startup. I cannot read very well up there probably because of the sunbeam. Are you doing anything on this benchmarking that relates to the safety and robustness of these smaller language models and how they fare in that context?
I'm sorry, it's like the echo up here. I can't really hear you.
Right. Are you doing anything on the benchmarking of these small large models or small language models that pertains to their safety and robustness, how easy it is to jailbreak them, and because performance pertains to drift, but performance also pertains to the potential to jailbreak them and have them towards more dangerous behavior or capability elicitation?
Not for this model, but definitely something that we can consider for the next few that we do push out, in that case.
Just raise your hand.
You good?
Maya from Aiden Corporate Development. So I think that SLM architectures are probably quite well suited to agentic process flows and agent swarms. So can you tell us a little bit about what kind of tool sets you have in that space? Or if you're developing them?
So I wouldn't in the agentic space right now, we're not in the development of like a small language model, like a hierarchical kind of swarm. But ways that I've seen people do this is with like federated learning and so forth, right? Where they can have a large language model sit at the top of the hierarchy and basically use smaller language models to be the agents that can go complete some of these tasks with different prompting as well. But the only thing is I would say to that is that it's not perfect, and then you also need like this centralized data point as well that sits in the middle so that the smaller language models have a place, like a knowledge base to get the information from as well. So that's like when you start to add decentralization and everything else like that, that's when latency comes into play. So this is something that I see a couple companies like Tensor, Opera AI they're working on, and RC and so forth. So we aren't necessarily working on that right now, but it is something to consider.
Hi, I'm Sungjun Nam, Number Analytics. We are statistical software powered by LLM. Our clients are concerned about data security. So the data we are working on, they don't want to send the OpenAI the raw data set.
Yeah.
Yeah. So we are thinking about to incorporate the SLLM in our server, but my concern is like the cost, definitely the cost and the speed and like how much like a budget should we have at least like for a startup company to get to the SLLM?
Yeah, well, I mean, it really depends on what your entire architecture is, right? So at Prem, we also do have a focus on helping you with like on-premise deployment. So if you do have the equipment for such, it can be done. And I think another thing to consider with the small language model is the fact that you're starting to see this evolution of smaller models being used on edge devices, your phones, your tablets, automobiles, you name it. And that will definitely help you lower your computational costs, because then you don't have to go out and lug an entire metal setup of GPUs, LPUs, you name it, whatever chips people want to use, right? And you can cut your costs significantly. But it does take time for the research. So it's hard for me to necessarily say how much of a budget you'll need, but I definitely will say that it can save you some money with a smaller language model just based off of the computational costs that you have.
Some like 10,000 or 100,000, like what is the minimum, the very, very minimum like budget you can say? Just give me some estimate. 10,000, can we start with 10,000?
I think you can start with 10,000 if you're going from an edge device, but you're probably gonna need a little bit more over time for sure. If you want to start it up, you can. And with our platform, you don't need $10,000 to start up and use some of the small language models and then also train them there. So you definitely can cut your costs significantly. So definitely come check me out, and I'm also here with my CTO as well.
Okay.
Yeah, so.
Great. Any other questions right now? If not, we'll.
In the back.
Oh, yes, okay.
Hey, you mentioned about function calling and RAG with small language models. Like,
Sure.
With 1 billion parameters, what is the context size? Because if I have, let's say, 20 functions, then the JSON schema for those might just get out of the token length for these. So I'm curious, like, what's the trade-off on how much data can a 1 billion parameter model look up with RAG or with function calling?
Yeah, there's definitely limitations in that aspect, but what I would say, like, right now, what I've also noticed through our work too is that small language models, like you have like BERT, right? That's like 500 million parameters, and then you have like a 1 billion parameter model and so forth. But like the nuance of what a small language model is definitely changing because larger models are getting bigger, and what can work on your edge devices and so forth is definitely changing. So now you could run an 8 billion parameter model on a phone, right? So a lot of things are changing now. So I would say, like, from this Prem 1B model, it's something that we definitely learned that maybe we can go and increase the context window and so forth, and go up, and maybe we'll do a 8 billion parameter model or 7 billion parameter model next as well. So I would say, like, from there, from 1 billion parameter model, you can learn that, how to do some knowledge distillation and continue to go up and up and up.
So is it like 2096?
Yeah. Exactly. Thank you.
Okay. Last question. Anybody? Going once.
Going once.
Going
and if
twice.
you want to ask any other questions about what we're doing with small language models, or what we're doing with Prem and our research and what we have with our SaaS as well, come find me. I'm also here with one of my teammates and CTOs as well. So I'll be right here at the summit all day. Yeah. Thank you.
All right. Thank you, Joshua. We'll take a 5-minute break and then come back with the next speaker in just about 5.
Hey,
Good?
great. Howdy. My name is Karok. I'm a professor at Texas A&M. I'm on sabbatical at Stanford this year. I'm a professor in computer science and in business. I study multi-agent contracting and multi-agent reasoning. So this is actually an area of game theory, which is sort of the foundation of a lot of what's happening right now in agent-based modeling. What I teach and research is Bitcoin, and so I thought I would talk a little bit about some of the research we're doing in our lab and how it might be relevant for you, and some of the look under the hood of what's going on in Bitcoin right now that could be relevant for agents, which I think is the future of Bitcoin, actually. So I'm going to talk about Bitcoin specifically, not about crypto generally, which is, I'm not here to offend anyone, it's just that's what I specialize in. Obviously, the biggest, I think, innovation in Bitcoin that I'll loosely discuss is 2 upgrades in Bitcoin in the last 5 years called Taproot and SegWit. And these upgrades have really expanded the computational complexity of what is now possible in Bitcoin. So I'm going to start with a few examples of what is possible now and what the use cases are now and what I think will happen in the next few years. So this is actually a diagram that I'm going to talk about of something called multi-signature. And multi-signature is, the idea for this is that, you've probably seen those movies where you've got like a nuclear submarine and you need 2 people to turn the keys to launch the bomb. That's an idea, that idea is called multi-signature. You need 2 people to sign for a transaction. So an example is that let's say you have some Bitcoin that you want to send out of your company, and you have 3 people, for example, maybe your CFO, your COO, and your CEO, and you need 2 of those 3 people to be able to sign for a transaction. That functionality has been around in Bitcoin since it started. Okay, next slide. And the way we would represent this in Bitcoin is that you would essentially have a small Merkle tree, and you would have one branch of the tree that would say, well, you need 2 of 3 people to be able to sign for this. But what would happen, say, if one of those, let's say one of those 2 of the 3, or 2 of the 3 people like went to a conference and they died, for example, if something happened to them, then you would not be able to send your Bitcoin and you'd be in trouble. So what could happen over time is you could degrade, it's called degrading the multisig, and that multisig over time can then basically downgrade to a 1 of 3 multisig. For example, after 30 days, it could go to just to 1 of the 3 people. And if all 3 people, for example, died in a plane crash, then after 90 days, it could degrade to a separate multisig, which would give control to another person altogether. So this is a simple example of a more complex transaction than is possible in regular life. But in Bitcoin, it's been possible from the beginning. Okay, next slide. So what's new now in Bitcoin since 2021, really, and it's really kicking into high gear now, is that these Merkle trees have gotten to be very complex, and they can now represent a large amount of data. And so we have, this is the taproot upgrade. We have, the root of the tree is called the taproot, and you can have inside of the tree not just like small data elements, but also entire scripts, which are programs. And these trees can be very large. So next slide. So for example, you could have trees of 128 levels deep. That's 2 to the 128 data objects that you can have in there. That's a huge amount of data that can be embedded inside of a tree. And all you need to store on the blockchain is just the root of the tree, which is a very small footprint. And so what, let's keep going. What is now possible, I think, is the real use case for these really complex transactions are not going to be human beings, like the example I gave you, but machines. Okay, so let's skip this. Yeah, so here's an example. Okay, so an example would be that now you have like 2 financial institutions, like a bank and a pension fund, and before you would be able to swap just Bitcoin. Now you can exchange essentially Bitcoin for data. And so the Bitcoin plus data, or Bitcoin for programs, and these programs can be embedded inside of these very large binary trees. Okay, next one. Next one. Okay, so so I think the real use case of this will be agent-to-agent contracting, not just transactions, where we're not just exchanging money itself, we're exchanging, large programs which can give different conditions for when that money can be spent. Okay, and so the framework of this is still essentially, variations on reinforcement learning. We have agents that are operating inside of their environment. They're observing the state of the world. They receive some reward from some action that they're taking, and that they'll iterate over in very fast cycles to be able to do this. Some of the leading research on this right now is happening out of DeepMind, where they are building out agents that are trading with each other. And I think the next step will be to be able to have those agents not just exchange payments, but really to exchange contracts with each other and to have really sophisticated economic relationships. So I'll give you some examples of some of these relationships that happen today in the economy right now, and why they would work in a kind of a Bitcoin-mediated economy. So some of this complexity, for example, is the U.S. government auctions off wireless across multiple states. So it's been doing this for 20, 30 years. And economists have helped design some of these auctions. And what's now possible in the last 5 years are called package auctions, where you auction off not just one state, but multiple states. So for example, T-Mobile may be willing to bid $1 billion for a California license, $1 billion for Nevada, but if you could get both, it'd be willing to bid more, $3 billion, more than the sum of its parts. And you can have a large number of combinations, like 2 to the 50 possible combinations. And this is too large for human beings to be bidding in these auctions. So what's happened so far is that they've had to simplify the auctions, where you can say, well, you can only bid, you can have packages of at most two at a time. But if you want the full complexity of the combinatorial auction, you would allow for essentially 2 to the 50 possible combinations, and that's where you really need an agent to help you both process that transaction complexity and be able to bid with other agents really quickly. Another example of this is how truck routes get allocated across the country. And so right now, let's say Procter & Gamble wants to send goods across the country. It outsources the shipping to truck carriers, and they can bid on different routes. But imagine that if you're one of the drivers, you're obviously willing to bid more if you can get the round trip, both San Francisco to Texas and back. And so that's an example where you might be willing to pay more for a combination than you would for the single route itself. Okay, this is too academic. I'll skip this one. Yeah, so this picture doesn't make sense because we don't have animations, but the essential idea is that packages of items are more complex than single units. For those packages, those are called unique combinatorial auctions, which are this area of auction theory that we research. And for that, I think agents are going to be absolutely essential. Okay. Yeah, you can't really tell exactly what's happening here, but the idea is that instead of just agents exchanging data itself, what you're really doing are exchanging these large Merkle trees, which have a huge amount of data inside of them. And they will essentially be programs that you're exchanging across the Bitcoin network. Yeah. So here are some examples. So this is a continuation, I think, of in cryptography, what's called secure multi-party computation. It deals with autonomous trade, so agents that are trading with each other, distributed data processing, prediction markets, which is one of my favorite examples, and games. These are all sorts of new applications that I think will be built on not just Bitcoin, but probably other chains as well. But as the most secure and best layer, I think it'll all move to Bitcoin eventually. Okay, I gave this talk in Vegas last, so this hence I had to have a little bit of colorful next one. Yeah. Okay, so some of the specifics here. Why is that in these games the Bitcoin protocol is really acting as the auctioneer. So we're moving away from humans being these auctioneers, but rather the software itself. And there are the cheap verification is essential for this to work. Next slide. Okay, so as you may know, blockchains are inefficient structures, okay, because they have a lot of redundancy because of for very historical reasons, mostly to solve for the double spending problem with money. What this means for us is that the computation is actually not all going to happen on chain. It's going to happen mostly off chain. Simply the verification will happen on chain. There's been a new development in Bitcoin in the last 6 months called BitVM, which is essentially trying to move the idea of the Ethereum virtual machine onto Bitcoin. And it's the short version of this is that you can have a full computation inside these large Merkle trees, but a very small, you just need to be able to verify whether that computation was done correctly on chain. That's a little bit of the technicals of how I expect it to work. Okay, next slide. Why is this better in Bitcoin? So you get the benefits of the largest and most secure cryptocurrency. You get settlement finality, the full decentralization, the secure computation, and backed by proof of work. And now you get the complexity and speed that is now possible. Okay, next slide. Okay, I think there are a bunch of other, I've been speculating here of further applications here of, 20 years from now, what I think will be some extra exciting areas where new markets can develop on combining Bitcoin and artificial agents. IPOs, the forward energy market, where you could buy and sell energy at any price in the future, not just according to a simple forward contract. Procurement, like the bigger version of the trucks, and space and property rights. I'll skip that one. Yeah. Okay, so stuff I'm saying sounds like science fiction. Is actually backed by a lot of research. Many of these are some of the faculty at Stanford that are still around today. So this is kind of the mix of academic research and what's happening now on the cutting edge of Bitcoin and AI. I founded the Bitcoin AI Institute, which I'm getting off the ground right now. I'm happy to talk about that to anyone who's interested. So that was sort of a 30,000-foot view of what's going on. Thank you.
Thank you, Karok.
Yeah.
Do we have any questions about this in the House?
Yeah, question?
Yes, hang on, we'll get the mic up there so the home audience can hear what you're asking.
For BitVM,
Yeah.
is that branchment, or what is that acronym for? You
Yeah,
mentioned
so it's a Bitcoin virtual machine.
Okay.
Yeah, BitVM. Yeah, look it up. It's got a bunch of new stuff happening.
Hi.
Yeah, hi.
Can you give some examples of the kind of scripts, that are in those trees that you mentioned? Like, can you be more specific, like, give us an insight into what happens underneath the hood there?
Yeah, so I think the multi-sig example is probably the best example historically of a script that's different than just a transaction. So that example I gave you with the 2 of the 3 multi-sig, those can be arbitrarily complex. And so you could have, let's think about an intergenerational transfer of wealth across a family members, right? And you have, you want to transfer money to your children or their grandchildren, and you want those funds to be activated at some point in the future with some group of people. There may be some subset of those group of people, maybe 3 of your 5 kids, but doesn't activate for 10 years or maybe 100 years. So those are some fairly simple, I think you can have complex versions of multi-signature scripts. I think the more interesting and powerful scripts are the ones that humans cannot really yet imagine, but machines will really take advantage of. And that's going to be essentially utilizing some of the, essentially having the machine intelligence experiment through reinforcement learning. What are some complex relationships between other artificial agents that can be represented in a Bitcoin script? All of these scripts are, Bitcoin is a very special language. It has a stack-based language. It's highly restrictive to prevent, essentially, it's like a cybersecurity feature of Bitcoin. And, but the taproot, the large tree size allows you for a lot of different complexity. Yeah. Yeah, sure, up
We
here.
have one right back here.
Oh yeah, maybe back there, yeah.
Can you talk a little bit more about the Bitcoin AI Institute, your vision for it, and what you're hoping to accomplish?
Yeah, sure. So this is a nonprofit institute. The objective is just to bring together these 2 bodies of knowledge that have traditionally been very different and siloed. Bitcoin and cryptography on one side, and then all of the new innovations on AI in the other. The reason I believe an institute is needed for this is because there's a lot of academic research on both sides, and there's a lot of foundational intellectual work that has to happen first, I believe. And then second is that I think the institute really should chart the path forward for the users of Bitcoin to be machines rather than humans. One of the problems Bitcoin has today is that its user interface sucks. And it's very clunky, and it's kind of non-intuitive for human beings. And that's why one of the reasons why people don't use it as much, because you have to deal with QR codes and private keys, which themselves are very large random numbers. And so all of this stuff is very hard for humans to use, but for machines it's very natural. Yeah.
Oh. Have you done any thinking around, currently Bitcoin is much more of a speculative instrument?
Correct.
So now you're adding layers of value on top of what is essentially a public chain. Have you thought about how that valuation is going to interact on a public chain?
So that interact with what?
So you're adding enterprise value
Yes.
with these apps on top of a speculative instrument.
Yes.
And it's riding on the same rails.
Right. Right. Yes. Okay.
Well, that question would apply to Ethereum or any like EVM, or it's kind of bringing, if I'm not mistaken, it's bringing Bitcoin a little bit closer with the BVM to what
Correct.
Ethereum's already doing, and that's already, a store of value.
More to an Ethereum model?
Well, that's a good question for our expert.
Yeah. So okay. So I think what's interesting here is that What I'm trying to, this area, I mean, Bitcoin's a big space, right? And it's got different pockets. What this pocket of developers and researchers are trying to do is essentially to bring Bitcoin back to its foundation, which it had a real use case beyond just storing value. I'm not opposed to storing value. I'm an economist. I do believe in the cycles of money, and the first case has to be store of value, and we will probably still be in that case for at least 50 years, and that's a non-trivial use case. But it still is time to think about, well, what can we do with that value after we just store it? And if we want to use it, we have to think, well, what are those use cases going to be? Given that Bitcoin is was born from the internet and from the guts of machines, I think it's a natural to link up the two, and that needs to happen now. Yeah.
Okay, so we'll get one last question.
Didn't Bitcoin SV try to do that to a certain extent? And where have they not succeeded, I guess?
Yeah, so there have been various splits off of Bitcoin in the past. I think this time is unique because of a bunch of random things that happened in the last 5 years, which I don't even believe the core developers could have anticipated. So the two big upgrades, the last two ones, SegWit and Taproot, were the two ones that really opened up all of this new capability of Bitcoin. And there were different reasons why they did it. Not to get too technical, but there was this thing called the block size wars in Bitcoin for a long time, and this was kind of one of the solutions was SegWit, was to kind of make this, to increase the block size without doing a hard fork. And so that allowed for SegWit and then eventually Taproot, which was designed to increase the transactional complexity of Bitcoin. I don't think the developers knew what could have happened after that. This last year and a half, the two big ideas were ordinals and inscriptions and BitVM. And those two big ideas unlocked this new capability from SegWit and Taproot that allowed for this that wasn't available back when SV was being proposed. So really, that's the historical what's happening. My view is that we should try to take advantage of this new functionality, and I believe in more use cases of Bitcoin rather than fewer. So I'm all for it. But not every Bitcoiner believes that. Just so you know. Yeah. Okay, happy to answer any questions anytime. Just look for me and my hand.
Thank you, Karok. Thank you for coming and bringing it.
Cool. Well, thank you for having me here. Hi, I'm Chris Butler, and I work at GitHub. I work in the AI team as a product operations manager, but I've done roles previously at places like Google's core machine learning group. I was at Meta, where when we called it Facebook, I was working on the Facebook Reality Labs portal device, doing identity, biometric recognition, and voice assistant integration. And then, I've worked at a lot of other places. You can check my LinkedIn if you want, but I think this talk in particular is just kind of my current thinking about the way that, say, like multi-agent systems and then agency in general will really come about, I think, in a way that is helpful. So let's go to the next slide, please. Thank you. Yeah, so basically, I want to talk about a little story about when I was working on the portal device, which RIP, if you've not heard about the device, if you want to go to the next slide. It was a video calling device mostly. It was something that was leveraging the Facebook's, like not only their network, but also WhatsApp. It had a lot of other applications. Actually, as part of it, I think one of the really killer apps was this idea of being able to tell stories through this animated storytelling thing between kids and parents or grandparents or something like that. I still have one on my TV, even though it's slowly dying because they've canceled the project at this point. But one of the things that really came up when we were starting to work on this was the idea of identity when it comes to devices inside the household. And what I mean by devices inside the household is that, if you go to the next slide, when we start to think about like all of the things that we use in our daily life, it's not just necessarily like our phone, but if we include something like the Portal device that's sitting in your kitchen, your Apple TV that's on your, like, you know, is some type of over-the-top TV device, even things like light bulbs, thermostats, and they're all kind of like intermediating different people through this type of technology. And so one of the things that we started to do was think about how is it that actually all of these things then join together to create a singular experience inside the home. If you go to the next one. One of the problems that we started to have, and this made me realize that maybe we have an issue with the way that not only people but devices end up interacting with each other, was this idea that with, say, voice assistant integration, we could do things like, you know, one person would ask for one thing, another person would ask for another. We wouldn't know how to actually intermediate those norms of the household. And what that started to mean to me was that actually all of these different nodes that are inside the household that are devices, people, things like that, it starts to lead us to actually a theory about agency, which is called the actor network theory, if you want to go to the next slide. And so it's really about this idea of like networks of people. And so if you go to the next slide, yeah, go one more. So actor network theory is a theory that comes from, I think, the 80s or 90s, which is really about this idea inside of socio-technical systems that there's really kind of like a couple key components that are common and something that we need to think about and utilize. So the next one. So the first one is actants. And so inside this theory, they actually don't make a differentiation between people and technical systems. And the reason why that is because every one of those things is actually gathering information, does interaction with the rest of the system in some way. If you go to the next one, we then start to talk about how the fact that all of these networks are actually being created between these different actors or actants. And if you go to the next slide, if you go forward, those networks actually are symmetric in the way that they end up providing information back and forth. Usually this could be something as simple as some type of system is queried and information is given back, but it could also be the interaction between a person and the device. So that idea of like voice assistance, me asking for something, another actant asking for something, those are both in some way dealing with the fact that then that device also has to respond back or do something to the environment. And if you go forward one more, it's really about this idea of like translation between different actant contexts. And what that means is that inside of this like socio-technical system that we maybe use as the household as an example, there's a lot of different information that needs to be passed around, not only between the devices, but also between the people that are there. Usually inside, when we talk about the way that people start to think about their households, it's all kind of governed by this concept of norms. And these norms are constantly changing. And it's part of the reason why actually probably smart home tech is going to be the hardest thing to actually figure out long term, because there's so many edge cases. And that evolution over time of norms between people ends up becoming really, really hard to always pin down. And that's because these norms are renegotiated over time as well. So if you go forward. And so I think, like, you know, coming to now, when I work on something like the GitHub, basically GitHub as a actual multi-actor system. So this may have started, if you go forward one, with this idea of, you know, we already are kind of a multiplayer type of environment, right? There's people that are all contributing to repos. You might even have certain types of automations that are already part of this that are also enabling all of those different people as actants inside of the system. If you go next. We then started to introduce something like Copilot, which is really one of the first systems for code completion. And of course, it's a very volatile, fast-moving environment right now. Cursor is something that is like actually capturing people's hearts and minds right now. I would say that Devin did not turn out to be what it was supposed to be. But I think there's still this issue of kind of like, we're now starting to create agent-like systems inside of this system that already has not only automatons or automation, but also other people. If you go forward, we also started to, we put out something in kind of a technical preview a little while ago called Workspace, which is, you know, again, kind of like Cursor in the sense that it's taking the ability to start to make changes to an entire repo rather than just individual files. And if you go one more further, and we just announced recently this idea of Copilot extensions. And so there's maybe a little bit of like terminology that I think we need to do a better job of inside this industry. Everything became agentive or agentic technology about a couple months ago, basically. When the reality is, like, for us, we start to think about the components of GitHub as a system, the repo as a object that is inside of this system. You need to be able to build something like a GitHub app to be able to access all of that stuff, including automations. We then start to talk about how there are skills that start to do particular key actions inside of that world. We then also start to think about the idea that inside of like an agent is actually something that has access to skills and the capability around being able to take action not only on repos, but then to call things that are outside of that. And so that could mean not just the idea of like, you know, I'm going to now help, the Copilot is going to help a person actually make edits to that repo. But we then can start to call other services, and that could be things like security services to make sure that something is within compliance. It could be automated testing systems. And so, anyways, I think like at GitHub, one of the things that we're really considering a lot of is what comes after this, when we start to now allow for multiple agents to then kind of do things together. We already have a lot of problems with people that have very complicated or complex automation systems inside of their repos, where they're constantly like stepping on each other, essentially. And so this is something I deal with because we build GitHub with GitHub, and so issues and projects are something that we live in all the time with our work. And there's a lot of automation that actually goes into this. We're just starting to go to the point of how do we start to use these LLMs to do things like issue summarization, meeting status and summarization, things like that. So from a product ops perspective, that's something that I work on a lot. If you want to go forward, I think there are a couple things that are maybe stopping us from actually having real multi-agent use cases. And so I wanted to just chat about these really quick. You may want to use a highly specific code model that's based on, say, 4.0 to be able to actually do the changes to the system itself. But I think the problem is going to be is that when these models are still incredibly large, when they're spending lots and lots of cycles, I think that this is going to be holding back people from utilizing it in maybe like cases where cheaper versions of things will work better from a heuristic standpoint. And I think actually maybe even robotic process automation is a good example of something where if you ask a model today to do an 18-step thing and do it consistently every single time, it's not going to work, basically. And so I think we need to get into this realm of understanding that there's still very much like heuristic or deterministic-based programming methods are still way more valuable for a majority of cases, but for exploring new ways of doing things, balanced against the cost is something that we can do. If you go next. I think there's like a big difference in expectations also. When it comes to the way that Copilot works within GitHub is that I don't think people always understand everything that it can do. And this is something that even goes back to just the reason why voice assistants within larger, like, you know, in things like Alexa or Portal, always just were used for reminders, timers, and music was because people don't understand the new things that are capable here. And so we need to do a lot more than just this idea of like prompt libraries. And I'm not sure what that means yet, but I think there's something with regards to getting outside of this like chat or voice assistant kind of realm and starting to think about how we integrate things directly into the kind of very, very specific interface for doing that type of thing. If you go next. One of the other roles I have at GitHub is I'm GitHub's responsible AI lead. And so it's not a glamorous job, unfortunately, but a lot of it is around compliance and governance, especially when it comes to like legal requirements around things like the EU Act, for example. But I think this idea of like how do we actually start to take eval, something that we call, I think a lot of people call kind of like colloquially red teaming of these systems is highly subjective still. And I would say a majority of people are really just using vibes to decide whether it's doing the right thing or not. And we need to build out a lot more of this infrastructure, something that we're doing in particular around harms testing. And in our case, harms testing is kind of unique because it's not just about the idea of will it say something mean to you, but it's also will it generate malicious code. And so I think for each one of these systems that you end up building using these types of agentive technologies, you need to consider beyond just saying bad words as like the harm testing that you can do. So I think that's another like really important thing that we're still just figuring out right now. And then next, I don't know, I think like when we start to talk about actants or actors inside of these types of networks, we do start to consider whether the discussion around alignment and the way that we need to have alignment with these technical systems in the future is actually beneficial or not. And the reason why is that agentive technologies will not just do what you expect them to do if they're going to be good at doing what they're doing. They will take a goal, they will try to do it, they'll check back in maybe, but I think like the vision we have for agentive systems may not actually be in alignment with the idea of alignment. And I think that's very interesting and something to, I guess, consider. So with that, I thank you very much. I just wanted to give you kind of like an overview of how we think about this type of thing, and I'd love to take questions and just chat about in general, like how we are starting to move towards real multi-agent use cases. So thank you.
Thank you, Chris. You have Chris's info on the screen there if you need to get in touch. And raise of hands, I'll see the hands pop up and run the mic.
Hi, Chris.
Hi.
Great stuff. I'm Nico. I'm the CEO of a red teaming company called Prism Eval.
Cool.
So I very much like the way you're framing the barriers to accelerating the agentic world.
Yeah.
You threw a bit of a list there. Where the bullet points in priority? First is the safety and performance, and last is the compliance. So how would you look at weighting the actual barriers and what you see? What kind of safety enhancing and guardrailing would you want to see in the world that you operate in? And I include language and code. You're absolutely right. It's about behavioral elicitation in all types of language. What would you? So number one is priority, and second, anything special you'd like to see?
I mean, I think most of the cost stuff is going to have to be figured out. I mean, there's a lot of reliability issues still with these types of like whenever a multi-agent system tries to be created for a production use case, it's very rare that it actually works out the way you want it to. And then if anything, I think that's why like I think we see creative work coming for this first, like the idea of like writing a piece of an article or something, is because there's a check that happens before it goes somewhere. It's very high latency type of work, and there's a benefit of this kind of like back and forth and tension between agents. But I would say like when we look at almost every other case of like robotic process automation, I don't think it's the right thing. So I think it's mostly performance and cost is going to hold this back. I think that, again, people are not really thinking about evals as much as they probably should, right? I mean, if we want to talk about like harm testing and guardrails, I do think, so there's some work that came out of the Google People Plus AI guidebook. And so I was there right before this helping with that. And of course, there's like 100 other people that were working on that project too. But the idea of like design policies is this idea of 4 different categories of kind of functionality in the way that a PM ends up writing their specification is no longer about requirements, it's more about behaviors. And so of those 4 things, one is like what is acceptable use, the way we want people to interact with it, what is kind of like just we don't want it to work this way. Where are there thresholds of uncertainty, which is that this thing will, because it is non-deterministic, even when we take it to the extreme of what I just said about alignment with agents, like what are the things that it's okay that it can go off and do something weird or not expected? But then there's like, what are the true vulnerabilities of like harm? And so in our case, we think a lot about malicious code creation, right? But I think if you were to take an example of somewhere else in some other industry, it's beyond that. Like you have to understand the use case and you understand the customer and the problem that they're dealing with and what harms actually could be there for them, right? And so, I mean, and we get into like a weird place with us too, because, for people that are, building out red teaming tools, for people that are doing pen testing, for people that are actually creating harmful test sets, that is actually, we want them to then create that stuff. But so there's like weirdness about when should that be allowed or not, essentially. So that's kind of like the latter, the way I think about it. I think there's still not enough testing of automation of the subject, like the eval in general. And I think harm testing should go right alongside that. Because you're always going to be balancing between this idea of like performance of the thing versus the harms that are there. And we're constantly trying to balance that for our, especially, that's why like prompts and prompt engineering it's still so much like an art, and it's so volatile between different model versions that we can't always depend. I mean, I would just say like, we're seeing the numbers go up and down when we like do things, right? And we change between different models. So I think there's like something about that we need to get into more of an automated test area, and I think that's good. But there's also like tons of false positives when it comes to like harm testing in some ways. So anyways, I think there's a lot more work that needs to be done there, but I think also PMs and designers thinking about this from the standpoint of like, what are the behaviors that we want to see or not see here, I think end up setting that up for then, we'll create a test suite that looks for these types of vulnerabilities, you know what I mean? And I just don't think we talk about that enough as like PMs or as designers. So yeah, that's what I'd say. Oh, I think there's a question over here.
Yep, come in.
Thank you.
Hi, thank you so much. I'm also a product designer at Cisco, and I was wondering, what's your thoughts and considerations on accessibility?
Well, I would say that accessibility is way further along when it comes to, not only like regulation, but also just the way that we end up grading ourselves on this. I would say, though, that just like accessibility, I think this idea of like checking off the box rather than actually doing the thing that is important. I think that our AI right now, responsible AI practice in general, while there are researchers that are looking into actually the harms of this type of thing, I don't think we do a good enough job of actually pushing like a good example is that there's just like all these very interesting cases that we need to start to worry about that are thematically probably pointing to a higher level need on how we make trade-offs around responsible AI, for example. And I'd say that's true about accessibility, right? Like, there's always the case that, based on your country or state, there may be different regulations around accessibility already. And so you have to at least meet those. But does that always create a better product for people that need that accessibility? And so I think there's a lot of parallels there. I just think that accessibility is a little bit further along in this journey, like by a decade, probably. And so we probably can learn a lot from that. There's actually someone else on our ops team that focuses on accessibility. And so we chatted about that a couple times. Just like, how do we start to learn the lessons from accessibility? Because they are further ahead than like the AI safety stuff that we have to deal with, or harm testing or all that type of thing. So that's what I would argue. But I don't know if that's a helpful answer, but that I think they're a bit further ahead is what I would argue.
Oh, wait, let's get that. I don't know if...
I just wondering, do you also test the AI assistant with the assistive technology or devices by any chance?
Yeah, so at GitHub, we do accessibility testing. Now, what I would say, though, is I don't think that we think about it beyond the interface right now.
Right.
I mean, you could hypothetically start to think about very interesting things where, again, depending on how you define accessibility, right? One of the things at Google that we were focused on was the next billion users, and that was really about how do we go to low literacy types of countries. And so I think there is something there about that. I don't think that people are doing enough work around that, but hypothetically, right? Just like all the concern we're starting to have about how chatbots, there was just a paper that came out in the last month about how it can change people's opinions or plant false memories, which is an issue for human beings in general, right? It's not just AI that's going to take advantage of that, but or LLMs or whatever. But with that case, I think we could look at the opposite, which is how do we help people understand better based on the context? I just was thinking about this idea of weekly minutes or summarization of status, for example. And I think we try to do that way too much at kind of the status level at the lower level, rather than the senior leader writing a manual or a prompt about what they actually care about. And so I think you could take that for the same thing for people that are cognitively impaired in certain ways, that understand things differently. Even synthesia, for example, you could maybe utilize that type of thing if you knew that about the person, to be able to have that translation from anything to anything property start to work better. And I don't mean to now say product managers and working with engineers is the same thing by any means, but I do think there's something about how, when you write a document as a PM, how does it start to actually create or update code? When engineers make trade-off decisions, how does that update the understanding by the PM? I think that's the reason why I joined GitHub, is because I think that type of translation type of technology is really, really interesting to me, especially in that context. But I think it's interesting. Yeah.
Now we got to go for our next question.
Oh, sure. Any other questions?
Just raise your hand.
Oh.
You said something about we might be building systems that are not in alignment with alignment. Can you expand on that?
Sure. What I guess I mean by that is that usually when we talk about delegation of something inside of a system, we're usually looking for the person to do the thing that you want, the end goal, rather than the exact way that they might do it, because they could discover a better way to do it. They could maybe even find a better outcome than the thing that they were actually told to do. And so I think if it's not, I guess maybe I'm being too pedantic about the terminology, but if you tell it exactly what to do and it does exactly that thing, that's called automation. And we already do that. That's if this then that. That's writing a program, right? That's just writing code today is doing that. So I guess the reason why we should be using these systems is because they come up with things that maybe we didn't expect. And that's where this idea of hallucination, someone just tweeted about today, the hallucination is not a bug, it's a feature, right? It's because when you use it in a place that is helpful, like creative writing or something like that, it actually is really beneficial. So I guess that's what I would say is, like, I think agentive technologies, especially multi-agent systems, if they continue to be expensive, they're mostly going to be for prototyping. And then what we'll do is we'll create an automation that is based off of that. And that's kind of how I start to think about the characteristics of these technologies. Like, I've been experimenting with this workshop called analogical innovation mapping. And so it looks an awful lot at the characteristics of technology rather than the specifics of it. And so those characteristics, you can start to match what are the use cases that are actually beneficial here. And so I think, like, when we look at the characteristics of LLMs and the way that they work today, they are better at coming up with weird things that you didn't expect. And so that's what I mean, maybe just circling back to the question, but it's like, if the LLM was always in exact alignment with you, it wouldn't come up with anything interesting. That's what I would argue. So, yeah. Question right here?
Coming right up.
I want to push you a little bit further on that, if you don't mind. So you're talking about alignment with a human user.
Yeah.
Earlier on, you talked about emergent norms. Are you seeing any patterns of alignment between agents, emergent norms, and systems of agents?
Well, I think, I would say that, so alignment is an interesting word, because alignment, I think, can sometimes speak to, like, especially in organizations, the power structures force people to align to something, right? And so we could say that, like, again, I really dislike over-personifying these types of systems, right? Like, I think there's helpful personification. But I guess what I would say is, like, because a lot of these, like, when we talk about a multi-agent system, it's actually just multiple agents that are represented through specialized prompts on the same LLM. And so what that means, like, yeah, and you can have different LLM models and stuff like that, but for the most part, when people are talking about this, they're using one LLM. They're just giving prompts to create different personalities for those agents, right, or different backgrounds or whatever, instructions. So I would say, like, I think there's already an alignment that's happened inside of that because of the fact that, like, all the way that are like the reinforcement learning that causes these things to be more human responsive, that is a type of alignment. I think when you look at, I think it's Anthropic with all of their discussion about, like, human values and the way that you try to respect human values. I mean, my counterpoint to that work would be that, like, MIT, they ended up doing a study where they took the trolley problem that exists and they had people from around the world kind of judge between those two things. And so what they found, though, is every culture actually judges things differently. And that, like, in the West, we consider young people or babies or pregnant women to be much more valuable, whereas, like, in more, like, in Asia, it would be elderly. And so, like, I think that's going to be the problem is when we talk about values, we're talking about values as, like, they exist for everybody, when the reality is like, everybody has their own internal values. Organizations actually have lived values, which you can see by how they make decisions. So I guess, like, yeah, sorry, I think I'm going a little bit off of your topic, but I think it's, like, related to this fact that, like, when we talk about alignment here, there is a desire to have things still stay within a bounds of what they're supposed to do. And I think that's where, right now, mostly that's done through the prompt engineering that goes into each of these agents, or the system prompt, or something like that, right? So, I don't know, but, like, would these agents, when the agents communicate with each other, right? Like, so here's an interesting situation. What would happen inside of a place where in a multi-agent scenario, one of those agents was prompted to lie to the other agents, right? Like, now, most of the time, if it's going to be inside of the system, it's probably, there's, like, a business development deal with an agreement, you know what I mean? Like, there are going to be people that will run open source multi-agent systems eventually, but I don't think you get around that any other way you would with other humans acting like that. It's just that a human wrote that prompt to have that agent lie in some way, right? So I don't know, I don't think that answers your question, but I think it's, like, a very interesting one, is what I would say. Yeah. Yeah.
Or is it,
yeah.
Or is it something that emerges digitally?
Well, so, I mean, Kevin Kelly would argue that the techium, which is, like, this idea of a strong emergent behavior of technology as parasitic with human beings, exists. And I would argue that most of these systems that I would refer to as socio-technical systems, there is strong emergent behavior from the standpoint of complexity theory. And so I think that's true. I guess the question is like, usually human beings in some way, even though it may be hard to get out of, like, the emergent behavior, because it's like, game theory, you know what I mean, type of issues where we're getting into these equilibriums that probably are hard to get out of because people are just like making decisions in a certain way. And so this gets to very philosophical places, but yeah, anyways. That's why I think like most PMs should actually be philosophy majors rather than technology people, but we definitely have to deal with that. But I do think emergent behavior is true, and we have to be aware of it, and we have to understand that it's not just technology though, it's the combination of technology amplifying and emerging behaviors that are human in the end, right? That's what I would argue.
I've got a question here. You don't mind staying up there, Chris?
I'm cool, yeah.
Okay, you're on a roll. I love it.
I don't know, I feel like that last question took me a little far out there, but like, well, we'll try to reel it in a little bit, okay?
Don't ask me to reel it in, because I'm going to riff on that question. I think, thank you for pointing out the paradigm of alignment is pretty useless for complex and agentic systems. It's also a very narrow way to look at intelligence. It's one of the problems we have in this AI community is no one
That's right. Yeah.
no one can really say what they mean by intelligence, but just speaking from what we know about biointelligence and how we go from our cell to super intelligence. Yeah. These are complex agentic systems that have diverse forms of cognition, many of which look nothing like an LLM or a neural net. And they're orchestrated. And there's hope there, because in our own life, we orchestrate superintelligence to be, I mean, you could say, beneficial to each other to some degree. I mean, it's just, I think that's such an important point, and thank you for saying it.
Yeah, no, and I think like also, you know, we need to consider that all this technology is human technology, and so it will, you know, it comes from the way that we think about what is valuable or beneficial or what is intelligence. I mean, I think there's a lot of interesting issues when we start to think about what would a truly alien like intelligence look like, and I'm not the right person to talk about that, but I do think that like there's a couple, you know, like Blind Sight is a great example of like a book that talks about an intelligence that does not have consciousness. And so I think like there's some interesting things to learn from that. That's all I'll say about that, but yeah. Oh yeah. Well, I think like, you know, when we start to think about like what is actually like complexity, there was a really great talk by the Santa Fe Institute just last week, and they just wrote an article in Aeon about the idea of like complexity is actually matter that computes in some way. And so I think there's something really interesting about that idea. So watch that talk, it's really cool. But I think it's all about like enclosures of emergent behavior is really what it comes down to. Yeah.
You mentioned?
It was Santa Fe Institute. It was their talk last week, and then Aeon. It was, I think the title of the article was Matter That Computes is Complex or something like that. So yeah. Any other questions or?
Well, I think we should move on to our next, and we have a burning question.
I have a follow-up to your earlier answer. You mentioned that agents can be used to build prototypes and then used to build automation. Can you give an example and talk a little bit more about that?
Yeah, I mean, like, here's maybe an example of, so one of the things that we've started to experiment with is, part of my job is to help set like meeting cadences. And I have a very high bar for meetings. Like, I think meetings are good. I gave a talk about meetings are good actually a little while ago. But I think like a well-designed meeting is one that is really, really valuable. And so what we start to do is we start to like ask these LLMs, and we have internal playgrounds for some of this stuff, where like what might be some of the misunderstandings or issues with this meeting agenda. I want you to now pretend to act like the people in this meeting. And so it's kind of, it's analogous to what we're talking about right now, which is that like, I want to use these systems to help troubleshoot, red team, whatever we want to call it, to build out what is this thing that will then become the agenda for the meeting. And so I'm drawing an analogy here where it's like, we don't know what would be best to get this goal basically within the meeting. So we experiment with a bunch of things. There's things I didn't think about, right? Like, and then that turns into something that's very rigid, which is an agenda that is more like a process. And so I guess that's what I'm saying is that, you know, again, there's a lot of things that just need to follow the manual, right? Like I used to work for a company called IPsoft that had Amelia, which was an over-personified chatbot and conversational agent. But in that case, like, yes, there was the ability or need to be able to switch between intents over time, but that intent of replacing my credit card still had to talk to the 22 internal systems at the credit card company to get a replacement credit card sent to you. But you could like act angry or sad, or you could ask it how its day was or whatever, and it would try to do all that stuff, but it still had to go through that process. So I think like coming up with the best, like being able to simulate allows us to then come up with ideas about what would be the best process. And then that process should be locked in some way. That's what I mean by that. Cool. Thank you.
Okay, thank you, Chris. Everybody, warm round of applause for Chris. Definitely super interesting stuff. Alignment, divergence. Where's it all going?
Great stuff. So, who wants to see an agent in action? Real life stuff. We love real life stuff. Great. People in the back, if you want to see an AI agent in action, then don't hesitate. So I'm Wouter. Nice to meet you all. I'm from the Netherlands. I was here for a week for work, and to participate in the hackathon, and in only 24 hours with people that I did not know before, we managed to build an agentic workflow, which is quite incredible. So we're going to show you today what it is, what it does, but I want to thank mainly also AI and all the sponsors who made that possible. Really, that helped us build the tool in 24 hours. So we built Miracle Pitch. And Miracle Pitch really is a miracle, because who has to sell in the day-to-day? Sell stuff, yourself or your company. Who needs to sell? Exactly. And selling is really a big hassle. Next slide. This thing is not working. No, now it is. So selling is a big hassle, right? People spend most of their time actually not selling, but researching prospects, getting insights, the whole shebang, which sucks big time, right? So we want to give back time to people to focus on what really matters, which is selling, right? This is a huge opportunity, multi-billion-dollar market, and there's a lot of potential parties out there, but they all have quite a static way of generating insights, providing leads. So what we did in 24 hours, we basically combined cutting-edge AI tools like Tavili, like Fetch.ai, Grog, Toolhouse, and together with that we built basically an AI agent that helps salespeople prepare their sales meetings, right? So it researches your prospect, it finds insights, it creates personalized emails, and it even creates a personalized video and does a phone call, which we will demonstrate. So here's a bit of the flow. There's a manager, of course, that has these different AI agents to his or her disposal, its disposal, and selects the best agent for the job to be done. If you go back, indeed, what I found most striking, and well, again, thank you AI-fi, is that, well, I met these awesome people, all different nationalities, all different expertise areas. Well, and that really facilitated also the creation process, I would say. So let us show you what we've built. You want to see it? Yeah! Great stuff, great stuff. So this microphone is low for me, Dutch person, way too long. So this is a Miracle Pitch. And Miracle Pitch, as we said, you just type in your query. So what do you want to research? You have a meeting with, let's say, Fetch.ai, and you want to, prepare your meeting. So you press, and then here you see the team. Because as you guys know, AI agents are different than traditional LLMs, right? Traditional LLMs just give an answer. It's an API call, it's an input-output. But with agents, you have different AI agents that can do different things, and the manager decides which one to engage. So you here see that the team starts working, and what it does, it researches, it describes the prospect, it goes to the website. So this takes about 3 or 4 minutes, but a human would take, of course, a full day. Minimum. What happens here is it researches the CEO or leadership team of your prospect. It finds a whole bunch of information about who they are, what they do, what kind of triggers you can use in your sales engagement. It summarizes recent news, right? This is a different agent that is focused on news. And here it creates, if you go back a bit, so up there, this is basically the script that is then injected into the movie, which you can then send to that prospect. So you basically have a video, it's loading now. You have an email, which is hyper-personalized, and you have a phone call. Here it is.
I'm reaching out to learn more about Fetch.ai's current sales process. Would you mind sharing how you currently engage with potential clients and partners?
Yeah, of course, no problem. But I'm sorry, who are you again?
I'm Soren from Miracle Pitch. We specialize in AI-driven sales solutions. I'd be happy to share more about what we do, but first, I'd love to learn more about Fetch.
Yeah, I'm not really into sales calls, that kind of stuff, but I saw your pitch at AIFI. So you make videos, is that correct?
We do create customized demo materials and videos, but we also offer more comprehensive sales automation solutions.
Pretty cool, huh?
Yeah, it's awesome. Fetch AI. Yeah, but I'd
Okay, so that's a phone call with an AI agent. And then indeed, eventually, as final cherry on the cake, it creates the personalized video. So this is a video, just to basically frame your mind, that an AI agent, a team of AI agents created on the spot for us to prepare our meeting with Fetch.ai, and it includes text, speech, and images that have been selected by the crew and personalizes the video.
Hi, Humain. Save time and simplify sales with our automated platform. Too many meetings? We streamline your prep with personalized materials. Struggling with onboarding? Sales Wizards gets new reps up to speed instantly. Need better sales presentations? Sales Wizard.
That's the Fetch.ai team. The AI agent selected that image for in the pitch.
Time with us today to become a deal closer.
And that's of course AI generated content as well.
Sales.
So basically you don't need to do anything yourself except for showing up on the sales meeting and acing the sales meeting. 24 hours. Great stuff, great stuff. Are there any questions? Sorry? I cannot hear you, sorry.
He's not here today.
Yeah. He's actually having sales meetings because everybody's interested. So, other questions?
Comment. I have the mic. I'll be giving the mic out.
Thank you. Just interested in what framework you used to put that together.
Yeah, so we basically used a combination of Fetch.ai and Toolhouse. So if you go to the different agents, Amir. So
for the agent itself, is it like LangChain, or did you just do it yourself in Python?
We did it ourselves. So it's basically a prompt that takes the user input and then based on the user input decides which agents to trigger.
Thank you.
Anybody else?
Anybody? 1 million, 2 million?
Where can we try that?
So we had 24 hours. We work in 24-hour sprints, and the next sprint we might make it production ready. No, and what I find quite striking, and that's, well, for me was quite mind blown because I arrived about 48 hours ago, and well, I'm here for business. I have a few AI ventures myself, and this was just for fun. But to see how these tools, like for example Toolhouse and well, the others, allow you to build AI agents basically with just a few lines of code, which blows my mind. Well, and will make enterprise solutions really accessible, in my opinion. Great. Maybe you can go to the PowerPoint again, because we do have a call to action, of course. So we are founders. This was just for fun. We might bring it forward. If you want to connect, if you are interested in what we do, then please, well, connect with us on LinkedIn, because we will be building a lot of generative AI stuff in the future, and look forward to doing that together with the community. Thank you again to AIFI for making this happen, and speak to you in lunch.
Thank you, thank you. And congratulations on the win yesterday. Okay. Oh, everybody is so compliant. We have alignment. We're better than AI, us humans. Okay, I'm going to... Daniele Bernardi, everybody, from Toolhouse.
Thank you.
This is one of our amazing sponsors who also powered a lot of the companies that built over the weekend. A number of them will be presenting here, showing you what they did, the four winners, the four cash prize winners. And I think we're going to run behind, so we have a pretty packed afternoon since we had to bump a few people from the morning. So take it away.
Thank you. Thank you, everyone. Thank you. And this is just the beginning. All right. My name is Daniele Bernardi. I'm the founder and CEO of Toolhouse. You probably heard a ton about Toolhouse already. I'll cut to the chase. We had this hackathon Saturday and Sunday, and we saw that almost half of the room became a paid user. 37%, I'm reading because I want to get the numbers right. 37% of all people who built got into the finals building with Toolhouse, and then we had 3 winners that won something with Toolhouse. Congrats to them. You saw some on stage here. Why did they use Toolhouse? Because AI is like this. It's 2024 and still it can't spell right, or it doesn't have capabilities to send the emails they generate or store memories for you. And developers spend a ton of time plugging these gaps. And they had to do this across all the LLMs they use. They, on average, use 3 in production. And so it's a waste of time. So with Toolhouse, we have a complete infrastructure that instead of having developers build the code that talks to an LLM, and then the prompt for the LLM, and then finding a way to host these things, we just have all in one layer. So you have all the building blocks necessary to build apps with great speed of development and with accuracy across all the LLMs you want to use. We have a tool store, so instead of building code, you just install apps just like you install apps on your phone. And it's really that easy. Just one button, install. And the developer experience is super easy, just 3 lines of code, and they work across whatever model you want to choose or whatever framework you want to choose. So however you're building, to us, it doesn't matter. We want to be as universal as possible. And so that's why there was an obvious choice for people to just implement using Toolhouse or use Toolhouse as the platform of choice for that. We also offered, and we still offer, $150 worth of credits. So if you're building something, you just want to try out Toolhouse, it's $1 at the gate. The reason for that was that our payment processor doesn't allow us to put things out for free, and I don't know, we need to fix it. But yeah, $1 for 150, I think it's still a pretty sweet deal, so get a hang of it before it's too late. Today, I had 2 fantastic guests to talk about the future AI stack. So what you saw is Toolhouse is a stack that sits on top of the models, but below the application layer. And Toolhouse helps you connect to other services. And those services sometimes are an API, but the API user is not a human anymore, it's a model. How does all the ecosystem change? How do things change? How do we need to consider this new pattern, and what things is this pattern going to change that we were now familiar with and unfamiliar? So without further ado, I want to invite on stage Ido Gino and Jerry Wu. Hello, welcome. Yes, take a seat. Mics should be okay. Hopefully, we'll get this sorted. How you doing?
Doing good.
Nice.
Doing great.
I love the excitement. All right. Obviously, before we start, Ido, Jerry, just quick word about yourselves. Why are you here? Why are you relevant? And yeah, prepared to get some good content from both of them. And I'll start asking you questions, and then we'll open up for questions from the stage as well. Ido?
Yeah, so hi everyone, Ido, super excited to be here. Spent the last 8 years building, actually more on the dev tools and API side, so working on a company called Rapid API, built the largest API marketplace in the world, so scaled to about 7 million active developers, 50,000 APIs. And over the last couple of years started developing the thesis that it's actually not going to be developers consuming most APIs. Within a few years, it's going to be AI agents that are going to be connecting to these APIs. And APIs are going to essentially act as the gateway between those APIs into all the different world of data and functionality that you can access. So yeah, excited to chat about that, and thanks again for the invite to be here today.
Jerry.
Awesome. Hi guys, I'm Jerry, CEO of Illuminate. We're building testing and evaluation infrastructure for AI agents. Talking about theses, I think what we're seeing is, and we fundamentally believe, is AI agents are a new way of programming, right? And the biggest shift with AI agents is oftentimes it's non-deterministic in terms of decision-making, tool use, or outputs. And with that, testing and quality assurance for outputs can no longer be deterministic, but needs to be non-deterministic, right? And so what we're helping engineers do is essentially be able to, at scale, check and evaluate how outputs are doing from a quality, coherence, eventually with AI agents, decision-making, capability, multimodal usage, things like that. Essentially trying to figure out what the testing and the quality assurance layer in this new stack will look like with more non-deterministic AI-based outputs.
Yeah, and I'm assuming, obviously, you've been in the space for quite a bit. Obviously, you wanted to start with the current state. I don't want to call it necessarily the past, because I see a ton of developers still figuring out, how do I get this big API request into a response that the LLM can consume? And so we're still in the world of things like JSON and rate limits and making the LLM think with the head of a developer. So in terms of current state, what do we see, and what are the big problems that the developers are facing when they plug in APIs and an AI model all together to do something meaningful?
Yeah, so I'm happy to start on that one. I think that the big revelation for me in that space was in a hackathon, not this hackathon, but about a year ago, when the whole agent and AI agentic workflow hype was starting. So it was an agent hackathon, and I walked around, met with a few different teams building things. And asked them, like, hey, what's the most difficult part of building this agent? And across the board, the answer was, surprisingly, the AI is actually the easy part. It's getting the agent to connect to an API, or getting it to communicate with some external system that ended up being the most difficult part. Like, what kept you up all night? It was, well, overwhelmingly trying to set up an application on Google Cloud to get Gmail tokens. Just setting up the app was the biggest challenge. But after that, it was rate limiting, retries, the schema doesn't match. We try to just pass the documentation to the agent, but the docs are wrong. It was, you know, what we kind of jokingly call the plumbing of APIs into those agents that ended up being much more difficult in the AI itself. And I think that that's kind of the sad state of affairs today. So we all had this great vision of, hey, you could just plug APIs directly into agents and that's going to work. It doesn't. That's probably where companies like Toolhouse and a few other teams are kind of coming in to bridge the gap, because it seems like API themselves are not going to be good enough. There needs to be a middle layer between the actual AI and the APIs it's consuming.
That's right. Like, initially we started kind of, you know, I hope you take this with flattery, but like looking at the Rapid API ecosystem, and we thought that the problem was in the ecosystem. Like, developers need to have access to like discovery and understand what can they use this API for, and then figure out the plumbing themselves. And we quickly figured out that that wasn't the problem. The problem was actually the technical integration itself. The developers pretty much know what the use case is. And it's the complexity of translating what was before built for a developer into something that now the AI can figure out itself. As an example, one of the most common things you can try and do, like, you can try it yourself. Some of you have laptops open. You can go actually on like a ChatGPT or Claude or your favorite LLM and try to say, generate code to perform a Jira request to close a ticket. And you'll see that they know they have already, these LLMs already have knowledge out there, and they don't have to study the documentation, they don't have to figure things out. But obviously that only gives you toy code. It's not ready for production, doesn't take care of the edge cases, needs to be reviewed, you need to commit that somewhere, you need to host it somewhere. So there is the discovery aspect that's in a way already sorted by the knowledge of the LLM, but still the plumbing, the implementation has a ton to be desired. And like you said, the middle layer doesn't quite exist or didn't exist up until, like solutions like Toolhouse and probably others. I need to yet to understand exactly how the landscape is going to evolve in that side. Another part is, how do we teach the LLM, now that it knows pretty much all the public APIs in the world, to act properly and how to be called in the right situations? And maybe, Jerry, maybe you have a little bit more context on that. Like, we talk about evals and like behavior of prompts and how to call this kind of LLM so they are useful and kind of deterministic-ish. But when it comes to like calling an external service, how do we instruct the agent to do that properly, and what are the common pitfalls?
Yeah, totally. I guess using this example with API integration, right? A lot of the users we see try to convert outputs into JSON formats, right? And let's say I have a JSON format that extracts from a piece of content, it's like an SEC filing. I extract the company name and then, most recent company summary on how it's been doing the last quarter. Obviously, with non-deterministic programming now, a summary of SEC filing is messy, it's noisy, right? And so as an engineer, the first step you need to do is integrate the tooling to get the JSON and the output to work in the first place. But the second thing that often many people reach is, okay, now that I've got this integration kind of working, how do I know if the prompt I've designated to pull this information or the information just on a baseline is correct, right? Many engineers today, they vibe check, they do manual reviews, they basically spend tens to hundreds of hours every time on every deployment push, reading almost the tooling integrations to see if it's working or not. And obviously, as many of us engineers know, that's not scalable, right? And so we believe the future of non-deterministic programming is non-deterministic testing or model-driven testing. Essentially, there's a lot of ways that are emerging out of research in which you can essentially use evaluation models, also known as LLM as a judge, if some of you are familiar with that concept, to essentially like recheck and revalidate outputs based off of your own criteria and assumptions on how that works. And to go into, I don't want to go into too detail, but it's very similar to actually normal software testing where you write a test script.
I was about to mention that, yeah.
Yeah, it's very similar. Like currently, software engineers, they figure out what they need to test, they write 100 test examples, and then they deploy that test script automatically on every deployment, like a CI/CD. Well, what we think...
And then the test breaks, and then you click ignore and merge anyways.
Exactly, yeah. Oftentimes, that doesn't work great either. But I think the future is evaluation-driven development, where instead of writing a test script, an engineer will define, say, an evaluation criteria, like here's quality or here's coherence, here's how I would define it. They'll probably also come up with some examples, right, on like, hey, here's what a good and bad example looks like. And then instead of using it in the script, you'll essentially train an evaluation model that will probabilistically grade your outputs based off of how you define it. And that's how we see the ecosystem evolving in terms of the testing component of this integration and orchestration layer.
Yeah, I heard, that's a very good point. I heard somebody was talking before networking, and this person said something along the lines of, like, there's a shorter gap between how an AI thinks and how a human thinks, but there's a wider gap between the way the AI thinks and the tools it has to use. And I think that was a very, I don't know if the person's still here, but it was like a very good remark, because that's exactly what there is. Like, we can model our agents or our assistants in ways that are kind of mimicking the patterns of how we as a human interact, and they seem to be responding pretty well to that. But then when it comes to making those assistants make the hook into the real world of being useful, then there's a ton. And so far we discovered what are the kind of complexities and the fact that there's a middle layer there that needs to be probably put in place to help both AIs and humans build something that's reliable, deterministic, and efficient. So maybe this is for you, Edo, like on what you see in like now going into the nitty-gritty of the implementation. Like one thing when I heard you talk last week at the meetup, it was about like really the complexity of figuring out how do we stop an API if it hit the rate limit. You know, as a human, you know, like there's a back-off process, you can measure things, but how does the LLM know how it's that configured? Do you do that in prompt? Do you have to still write code for that? Like, what are the complexities related to the actual implementation of it? And how do you see businesses, companies, maybe startups and other founders solving for that?
Yeah, so I think, I mean, you mentioned obviously, you know, rate limiting, retry, authentication workflows. I think kind of zooming out a little bit, what a lot of people are realizing is there's this classical thought process of, hey, like when you use an LLM for one interaction, even if it's 99% accurate, that's pretty good. But when you start using an agent and now there's n many steps, you start combining that 1% error rate, and suddenly the error grows really large. And when it comes to APIs, it's very easy to create a very long chain of actions that need to be taken, and then you create a huge kind of opportunity for mistakes to happen. Yeah. So I think that the kind of best-in-class architecture, what we see happening a lot, is just creating smaller components that outsource a lot of the complexity from the model. So even just something like, oh, you need to get a authentication token, then you need to exchange it for a code, or like you get a code, you need to exchange for a token, then you need to go make a request, that gives you the ID of the item, and then you need to go get the details for that ID. So there could easily be a chain of like 5 different actions that you need to do with an API. Now you could have the actual agent do all 5 of them, or you could put that into some other service, basically expose it as a tool, and I'm really, this is not a paid advertising, but expose it as a tool so the agent gets a much simpler actual endpoint that it can call on. So instead of saying, hey, here's the whole documentation for the Salesforce API, you can say, hey, here's a tool to get an opportunity from Salesforce. And the agent doesn't need to think about all the complexity that happens behind the scenes.
Yeah, that, you made me also, like, 100%, because obviously, you know, as a founder, I saw the problem. The engineer in me still thinks about, you know, what are all these moving parts and bits and pieces. And I think, again, that's the fundamental disconnect I was referring to before. Like, we tend to kind of offload most of the complexities to the LLM, but then when it comes to the actual implementation, the LLM can actually figure it out if you're simple and outcome driven, and that's where like most of the complexity is. Like even if the implementation is easy, then the use case that the LLM can use and the use cases that the LLM should not use, those are the things that are important. So those are basically part of what we call the guardrails, you know, in the prompt. To give you an example, in Toolhouse, probably the simplest possible tool we have is a tool to get the current time. Like, believe it or not, but if you call the LLM through an API, it cannot tell you the time. So obviously, you know, it's probably a one line of code, that implementation, but then how do you make sure that the LLM knows what's the current time zone of the user for a client-facing application? How do we know where this time tool can be used or not? Those are all the things that developers now need to start thinking about. Before, a developer could just like write the integration and, you know, go on about their day. Today, there's much more, and there's simply not, that's not part of what a usual engineer had to do. And so that's more where most of the new complexities in this new API world need to be.
Agents work with the current state-of-the-art models. And then you go and solve all the problems that we've been talking about. And now we're actually making progress. So I think it's actually a good time to build agents, because you don't have to keep answering the question like, well, what happens when GPT 5 or 6 come out?
That's right, yeah. Thank you. Questions, I'm sure. Yes, here's one of the...
1 sec, I got the mic over here.
Yep. Right over here.
Thank you. You mentioned Dreamforce and the agent force, billion-dollar agent. So I wonder how you guys see whatever Dreamforce and Salesforce is trying to do for agents in the enterprise. How is that going to impact the ecosystem, if any?
No, it's a great question. I mean, I don't know, because I don't know the full extent of the Dreamforce product. I do think what we're going to start to see more and more often is, obviously, when it comes to enterprises like to build on top of the data that they have, specifically the data security that they have, right? So in terms of us, I think Dreamforce is really exciting for enterprises who already have a lot of data in Salesforce, right? And that gives them an easy platform to immediately build on top of. I think the reality though is that today most companies are multi-cloud, multi-platform. The data is everywhere, right? And so when it comes to actually building agents, and also agents need to interact across not just Salesforce, but like every other database or internal tool that they have, right? And so I think there's going to be a lot of orchestrators, both within companies that have platforms that offer agent building, as well as opportunity for companies to build across platform or across platforms that are open source or data areas that companies don't have built on top of, things like that. So I do think it's going to be a really wide ecosystem. And Dreamforce is a great start, and it gives a lot of, I think, enterprise validity to AI agents, and I think that's what's really exciting.
Right. More questions?
Yeah, thank you. There was one concept mentioned earlier that I'm hoping to get a bit of clarity on. You mentioned the idea of, instead of having a sequence of large language model steps, to separate out the code into a separate service of some sort. Was the idea there just to take away as much of the work as possible from the language models and have it in codes for reliability purposes? Was that the concept?
Yeah, so there's a couple of, I would say, sub-patterns that we see there. One is you take a lot of the logic that is often coupled together and you just extract it into like another piece of code. So a good example is, let's say you want to let an agent search through your inbox, like your Gmail inbox. So you can just give it pure Gmail API access and give it your token. It will go and it will refresh the token, and it will use the search endpoint and get like a bunch of message IDs, and then use the get message detail endpoint with an ID to actually get the message, and then parse it and get back the text. And it could do all those actions, or you could just take all those actions and abstract them out into a single function, like a single tool that you pass the agent that just says search emails, and you pass it a query and you get back the email bodies. And the agents tend to be more accurate when you take more of that work out of them, so it gets like a nicer logical component. The other pattern that we're seeing is when you have those agents and they're communicating with a bunch of different services, making sure that there is something between you and those services, both for observability and control. So you want to make sure that, for instance, you actually know which emails your agent read. You want to make sure that there's some observability around that. You want to make sure that it doesn't just go and randomly start deleting all your emails. So you want to protect maybe some functions. You want to maybe rate limit how many emails it can read or write at a time, because you have a bigger rate limit from the API itself. So it just basically making sure there is a layer between you and the service, between the API and the service that it's consuming, that can add a lot of that observability and protection.
Yeah, those are, by the way, all patterns that obviously we see emerging, and it's kind of a cat and mouse game, at least from my perspective. Like, when I started this company, I started because I felt this problem myself. I was working on a previous project where 80% of my time was building the tools and making sure that those tools could be actually turned into agents, and each agent could talk to one another, and then making sure that the output would be okay. All this orchestration takes a ton of time, and developers are always playing catch up with whatever new trends and technology comes. And obviously the speed, the pace of evolution in the AI world is, I don't know, breakneck. It's like very, very high. And so you spend a ton of time sometimes for nothing and working on things that are very experimental, like fresh out of research sometimes. So can we make these things easy, and can we make them more reliable so that they could be, their usage, its usage can be democratized? I think it's the real challenge, and we're starting to see some direction there too. See more raised hands? Yeah. Hi.
Hey, can you hear me? Yeah, so question for you, someone that's like really new to the space, just like, I guess like, first question would be like, any sort of resources around agent or agentic AI where the best sort of like marketplace, like something like that, where if you're a non-AI background engineer, you just want to get started, do you have any like recommendations there? Or would you say it's like so simple, it's like you just got to do it yourself, and then like resources around that, like building out your own agents?
I'll let you go first because I have a strong opinion on that.
I think you just build and solve the issues as they come. But curious to hear the strong opinion.
All right. So.
And do it with Toolhouse, obviously.
Yeah, like, except for Toolhouse. We are too biased for that. But no, like seriously, it's like sadly, my answer is I don't know. I don't have a good resource for you, and that was the problem for me as well. Like, look, I have a degree in computer science. I've been doing this job for like, I don't know, 15, 20 years now. Who's counting anymore? I built the first, not to flex, by the way, like to tell you like how the complexity of the things I had to solve in my career. I built our at Facebook when I was there at Facebook. I built the first recurring payment service internal because we couldn't. Like we had this huge not invented here syndrome, so we couldn't really buy anything from the outside. We had to build it ourselves. So I had to like figure out like how credit cards work, payment gateways, all this kind of stuff, and just like code the subscription, the first subscription product for then Facebook. And now I come to 2024 where I feel like I'm losing my brain power because I can't find the right resources for me to get started, you know, and fundamentally, I believe that kind of feeling where you like have accomplished things and then all of a sudden you feel you can't get a grasp onto something is wrong and needs to be fixed. And there's a lot of the kind of overhead on all these like buzzwords like copilots or agents. So like one of the questions I had on Saturday during the hackathon, we had a workshop and somebody interrupted me, rightfully so, and said, we're talking about all these things, and those are great, but what exactly are agents? You know, like what is the implementation? Like at the very, what are the ingredients? Like at the very foundational layer of that. So it's an LLM and a prompt, and then on top of that you have tools and memory. Like nobody explains these things to you that easily, and that's why I don't think we are doing a good job collectively as a tech community to really go down to the basics and allowing everybody to get started and to get a grasp of it. So if we can learn something from this, is exactly that we need to make things accessible to people and very simple. And that's one of the founding principles of like Toolhouse. Like you don't have to really look at a new agentic framework with Toolhouse. We have 3 lines of code. You're probably starting with like LangChain or Crew AI or Llama Index. We just plug Toolhouse into it. You don't have to learn us. Just learn you already have a ton of learning and education that you have to do for yourself. So focus on that, and then we're there when you decide to stick with one of those frameworks or technology.
Really quickly, I just want to add, totally agree. I think you just need to build. You said like, how do engineers without AI backgrounds get into space? I actually think like fundamentally, most engineers can do this without any ML background nowadays, right? Because at the end of the day, a lot of the work has been abstracted into functions and APIs. I saw like a LinkedIn post the other day that was like, if you want to be an AI engineer today, you need to know like linear algebra, like Gaussian, like regression. I was like, that's just not true. Like honestly, if you're an engineer and you know how to like call APIs and you know intuitively how to do systems designs, you can build amazing products, right? And like I think it's the job of the researchers to abstract. I think increasingly it's the job of the researcher to abstract all that work behind a microservice. But like for the everyday engineer, you don't need any of that background nowadays. I think you just build and have fun with it, and like it's pretty easy to figure out.
So there's 2 more questions. And in the meantime, just want to do a quick time check. Are we okay? We on time still? Okay.
Mine's quick. To the gentleman who asked the question, deeplearning.ai is the resource for you, deeplearning.ai. A ton of free classes to learn all about going from traditional software development to working intensively with large language models. So.
There you go. Mark has solved on you and Stack Overflow.
I don't know if I want to use this, but piggybacking on what he asked, there's a lot out there for people who don't code, and you can use this tool without coding and that tool without coding. But if you're building a real product, right, if you want to build something that's consumer facing or B2B or whatever, you know, do you have a perspective on what this orchestration layer is that you guys have all mentioned on some level? To me, I've been in this business for a very long time, it seems like there's still your traditional application architecture, right, that a lot of these LLMs and APIs and all of this fit into. So like you mentioned context, you know, wouldn't you still get some kind of context from your overarching application layer into that system? Because I still see the orchestration as happening elsewhere.
So there's a lot, and picking back myself in turn to what Ido said before, like all these things today happen because GPT 5, 6, 7 is not out yet. And so there are like kind of 2 schools of thoughts. Like one that believes that we need to get to this because fundamentally AGI is never going to come and people wait at the door. Those are the 2 aspects. And so all we talk about, like limits on context or orchestration layers or networks of agent swarms are, and I'm going to obviously generalize and be more very much the basics of it, are things that we put, abstractions that we put in our code and our architecture to overcome most of the limitations that these foundational models have. In the future, as models evolve, those patterns will evolve until we will have reached a point where those things are stable enough, you know, and the architectures are going to be consolidated because the foundational models can handle things in a much better way than we do today. So right now, we see some agents deployed to perform smaller tasks just to overcome what's called context poisoning, where you put too much information into the context, even if the information fits the context, but the nature of the information is different. Maybe first you talk about shoes, and then you talk about sports, and then you talk about the user memories, and then you talk about calling tools, and then the LLM confuses itself. It doesn't know what is the relevance of one topic to the other. You know, if you break down each one of these categories into an agent, then each agent acts in its silo, in its context, doesn't need to know about all the other categories. And then you need to piece all the results together in the results. You know, this is just because of the limitations we have today, but maybe tomorrow that's not necessary anymore. We're seeing this evolution in computing, in other areas of tech, you know, since like, I want to say like the 1960s. So I think for me, at least personally, I see history is going to repeat itself, and we're going to see patterns evolving until the technology is ready, mature enough, or like the shoulders of the giants we stand on, the foundational models are going to be very discrete enough, but also stable enough for us to build reliably. I think there was a question in the back.
Yeah, great. So I first have a comment, case in point, about indeed everybody being able to write code. So I haven't coded, the last 12 months I started, right? And then with Cursor and Toolhouse, basically we won the hackathon, right? Which, well, that's basically case in point. Thank you very much. And, well, I think everything is made extremely easy. My question was about deterministic versus non-deterministic. So if you're going to tell these agents, like, you have these tools, and if you need them, use them, but then you have a non-deterministic agent, how do you handle that?
Who wants to take this?
I mean, I'll actually add that I think that's a kind of back to abstracting the tools and adding that kind of protection or middleware layer. The non-determinism is a big reason why you need that sort of layer, because you have agents that are not fully predictable and they don't fully understand the implications of using a tool. So that's why you kind of need a system of checks and controls over what the agent can and cannot do that is distinct from the agent itself. It can't just be, solving it by giving an extra line of instructions like don't call that tool too many times because it's really expensive. It has to actually be a kind of third-party checks and balances kind of system that can control or be external to the agent itself.
I'll add, ultimately, non-determinism is a feature, not a bug, right? Like, the non-determinism is what gives these models the creative flexibility to make decisions and act based off of prompts as well. And so I think the other side to this, I agree, I think tool usage definitely needs to be as deterministic as possible, right? But I think if you think about the overall agent output or agent decision making or capabilities, there's no way to get determinism. I think what I like to say is what you really want is alignment with human expectations or engineer expectations, right? And it's not going to be perfect, but you can get as close as possible because ultimately agents are trying to extrapolate human work, right? And humans aren't deterministic machines as well. So I think there's a difference between the determinism of the tools, which is, I think, one problem, but then the non-determinism of the overall AI agent system you're trying to build, which is a different problem in and of itself. And I think actually just this thing that engineering and business culture needs to accept is going to fundamentally change.
Right, we forget that we want an LLM to act like a computer, but it's not a computer. It's modeled after the human mind. And it's scary to think about it, but it's really like that. And humans are creative. Sometimes they take shortcuts. They always improve. They always find different ways to do a task, all we do by nature, if we do a certain action twice, if I repeat the same word, it's never going to come out twice exactly the same. And we should think about AIs in the exact same way. What we expect, though, is that when we drive our car should always be working, from when it takes us from A to B. Its brakes better be working all the time, in the same way, in a predictable way. A car is a tool we use to perform some actions in life. And that is what you were actually mentioning. The output of the tools should always be deterministic. And sometimes that's a challenge in itself. And again, one of the reasons why I built what I'm building. But when you feed that tool to the LLM can reason, the LLM can think, the LLM can sometimes find a different way and maybe use a tool once and then not use it anymore in the same context because it knows that I used it before. And so there's no reason based on the nature of the tool to use that tool twice. An example, the calculation is never going to change. The same inputs are always going to produce the same outputs. So if the LLM performs a calculation at the very beginning of the chain and then down the chain still can reference that result, it's not going to call the tool twice. And that's kind of the thinking ability of the LLM. So understanding this fundamental aspect about building useful apps and products for that use AI is going to be the change in mindset. Think that you have an additional brain that can think, except this brain, again, scary, it's in a computer, but it's not the computer. It's really a mind on its own.
Yeah, and I like kind of what the point you made about the non-determinism as a feature, not a bug. I think there's a long time where people are trying to kind of fit AI into the kind of model in which you were used to thinking about software development. So I think it was, I don't remember if it was Anthropic or OpenAI, but they released a feature where you can give like a constant seed to the AI so you can get constant responses. And one of the big selling points was like, oh, your unit tests can now run and like test the AI. No, you should just think differently about how you're doing testing. Like doing a unit test with string compare does not make sense for AI. It shouldn't work.
Right, yeah. It's interesting that they are kind of taking a step back and they kind of pleasing the kind of behavior, reinforcing the kind of negative behavior that shouldn't be there in the first place. So very interesting dynamic. I think we have the question here in the front. Last question. Last question.
Last question.
So this one's on data contracts, right? As we start to look at Agentic AI and the demand that it has for, this is probably going to suck. As we start to look at Agentic AI and the demand that it has for exposing internal data and functionality that we previously probably kept internal, the idea of how we define the APIs themselves, the data contracts that exist, probably has changed over time. So I kind of have this as a two-part question. One part is, how have you seen that kind of data contract writing change in your own work across the space that you've worked in? And two, similarly in tool definitions, as we start to look at like LangChain tools and that framework sense, have you seen those definitions change and get better over the past 6 to 9 months?
Happy to take the first part on data contracts, because so my last company, Rapid, we kind of help companies internally set up their API catalogs. And pre-AI, there was a big part of the value proposition of saying, hey, you're a large company of thousands of developers, they're expensive. You want to make sure that they can actually use your APIs easily. They should be documented. Like bare minimum, you should actually have a document somewhere saying what the API does, the inputs, the outputs. And companies always chronically underinvested in the space. And then we suddenly had, this was a couple of years ago, a big Fortune 100 company, like everyone in this room would know who they are. And they came to us like, hey, we have a huge mandate, like we have a huge budget, millions of dollars to invest in getting all of our APIs documented, because AI is going to start connecting to APIs and we need to make sure that the AI knows how to access them. It's like, well, like, glad to hear you're more like considerate for your AI than your developers, but like, yeah, about them time. So I think like, at least now people are starting to document APIs for a change.
Do you see any structure to that that's constant?
Open API files. I think there is a bunch of startups doing really interesting things in how you define APIs with more usage examples and more dynamic documentation. Honestly, just having an open API file with a list of inputs and endpoints is like miles ahead of where 90% of APIs are. So there's a lot of cool stuff, but just catching up to the bare minimums is where I think there's a lot of gains to be made.
Amazing. That's all the time we have for that. Thank you.
Yeah, one more, just to reintroduce yourselves, because we'll get the name slides up with the contact information. So we got Ido and Jerry and Daniele. Thank you very much. Big round of applause.
Thank you.
Okay, next up.
Just show of hands, who here would consider themselves kind of new to the space? Just raise your hand. All right, and then who here is prototyped something, done a hackathon, like yesterday or this weekend with Steven? Awesome, more than half. And then who's actually productionized a viable product and consumer faced it? Okay, fair amount. So my name is Dat. I'm a solutions architect here at Arise. So I'm technical, but I do like to explain things in a way that makes a lot of sense for folks. So I'm just going to keep today pretty educational, not salesy. So one really cool thing I have access to is our customers. So we have really amazing logos that we work with. So you can think I work with some of the best LLM teams in the world. So Booking.com, if you just Google trip planner, it's actually, it provides revenue for Booking.com. You can think it's a travel agent in LLM form. So you can say, hey, my name is Dat. I want to go to London with my friend on this date. It'll do everything from book your hotels, your flights, even give you a nice itinerary. So what I wanted to give, I guess, the audience today a little insight into is how do you build a viable LLM product? And then for the folks who are kind of new, what are the steps that you can take to kind of get there? But I think that's the ultimate goal. And so I guess when we think about kind kind of the major problems that most LLM teams face. And just to build a little bit more credibility, we also built, like, how do I know about this LLM journey, and how do you know that I'm not just like using hype words? We actually built our own Copilot. So here at Arise, we actually built, you can call it a Copilot, you know, a software process that uses an LLM to help our users debug their own models, whether they're classic ML models like ranking, regression, classification, or even LLM models. So you think we purpose-built an AI to troubleshoot other AIs. You can read this blog post, but it's in production and customers use it. So just to build some rapport on, like, if I know what I'm talking about, maybe this could help you kind of understand. And so I think one of the first things that we learned when we were building this Copilot was, like, it's this lesson from software engineering. If you want quality, you need to approach it with velocity, right? Meaning, in these testing cycles, so Arise Phoenix is our open source. We're an observability company. We help teams understand if there's an ML or LLM process that's broken, how do I fix it? How can I be alerted? How do I make things better over time? And so when you think about what do the best LLM teams in the world do, well, the first big unlock is you need to get through more iteration cycles in the same amount of time. So if I can get through 5 iteration cycles this month versus 2, you can imagine you can build a better quality system over time. So I think most people from software engineering can understand that. And so when we think about the major unlocks, the first one was just getting trace data in, right? So if you don't understand, like, telemetry data, you don't have to. You need some sort of visibility on your process, right? So I have a little code example here. It's just this simple kind of LangChain app. Going past this, but you can use it LangChain or LangGraph for some simple agent process. And all you'll really do is, if you just take some, like, cookbook, you know, from one of their docs, whether it's you know, from LangChain or Llama Index or any of the various agent frameworks out there. This is our open source, so you can just add this little line of code right here. And the line of code is just this whatever framework.instrument, right? And then what you get out of it, and so if I go back into the code, I ran that instrumenter up here, sorry. There we go, right here. So I ran this one line of code in here, and then what I'm left with is this view. So what is this view? If you can imagine, a chain or an agent has kind of many processes. You know, I can pop open one of these kind of chains and just show you. So, for instance, in this particular chain, I went and, you know, might have retrieved some sort of documents, right? Ran some sort of chain or process, maybe ultimately called some LLM kind of process, and now I have, like, a view into, like, what happened and kind of why. And again, this structure here, this trace structure, can just vary depending on what you're doing. Again, not every process that you run is going to have the same exact kind of, like, control flow or pathing. And so just getting visibility into it is one thing. And so that's your first step in, like, how do I start building a better quality system, right? And so once you're there, then you want to do things like find issues, right? So you need some sort of signal from your application. And this generally comes in, just from an education perspective for the new folks, 4 kind of ways. So in the industry, there's kind of 4 meta thoughts here. One, I can discern signal from my users. So they can either give me a thumbs up or a thumbs down to tell you how my experience is going. So most people are familiar with user-provided feedback, but basically, if you've used ChatGPT, you get a thumbs up, thumbs down sometimes. Most people get that. I think Jerry said it earlier, but LLM as a judge, probably one of the most popular ways to evaluate for maybe the new folks. Yeah, it's just using an LLM to give you a label on some sort of process. You can define what the label means and define it, but super important. You know, as folks are building, maybe more mature teams use things like golden data sets. It kind of is an ode back to, like, unit testing, but you can imagine golden data sets as, like, I have this curated set of examples that I've kind of hand labeled, right? And I know the outcome should be X, Y, or Z. as my system changes over time, I'm just going to run that test and say, hey, are my golden data set examples doing the right thing, or maybe they're not. Maybe I'm producing the right output, maybe I'm not. But it's akin to like unit testing kind of over time. And then little pro tip from really solid teams. Sometimes you need to evaluate your evaluator. So for the folks who are using LM as a judge, little pro tip, you can actually run your LM as a judge on a curated or one of those golden data sets, right? Because at the end of the day, your LM as a judge is just a label. But is there a way to like measure how well the LM as a judge is actually doing? And so what you can do is, if you run your LM as a judge on things you've already graded, what you might get back is something like this. I'll just show you an example. Here, I'll just choose like the hallucination eval. But the idea is like you'll get kind of like a confusion matrix back. So if you know what the correct answer is and you have an LM as a judge, and the reason why people do it is because curated data sets are about like quality, right, and coverage. They're not generally scalable because a human has to do it. But the cool thing about LM as a judge is that it does scale. It scales into data you don't have to label yourself. It's a little pro tip there. And then I think number 4, most people forget in this world. It feels like most people's LLM applications are just kind of science projects and they don't actually give a return on the business. Make sure you're also measuring those kind of business kind of metrics. So for instance, for Booking.com, they measure things like DAU, MAU, retention rates, thumbs up, thumbs down, but they're also measuring like things like CTR. If I recommend flights or hotels to you, what are the number of times you're clicking on those things, right? They want to build this LLM agent to produce revenue for them, right? It's a personalized travel agent. So those are kind of the signals, and then maybe I'll flash this kind of architecture slide. I have opinions, very strong opinions from the technical side. I don't think fully autonomous agents work in production. They don't. I've never seen anyone productionize it across my tenure. So what actually works? Well, when you think about why fully autonomous agents don't work yet, I am bullish, but they don't work yet. The reason why they don't work is because the solution space is just too large, right? Like, think about all the things you can ask something to, and like have it access your systems. Anyone who's built in the space knows this. So what do you have to do to make things actually work into a viable product? Turns out, you have to bound the problem down, right? So this is what we call like a router architecture, very simplified. They get much more complex. And most of our customers handle their own like orchestration. Basically, the software engineering is done by them, which kind of makes sense. My other hot take is the only framework you should be using is your coding language, but that's my own hot take. Now, what is this I'm even showing you? So let's say you're like Booking.com, right? And a customer comes in. They generally have some sort of intention, right? Like, hey, I want to search for new flights, or hey, I need to do a comparison between these two flights. So generally you have this thing called like a router function. It's just the control flow of the application, bringing it back down to software engineering. So based off what you intend, and it could be an LLM call. Some people actually use an NLP classifier because latency is much faster. Just depends on what you need. It'll actually send you down like some branches. Some people call them tooling, some people call them branches or skills. You can imagine each one of these kind of paths as being, a series of maybe LLM calls in sequential or parallel. Maybe there's, API calls or RAG calls or tooling calls. Maybe there's application code or heuristics. But the whole idea is the same. You've kind of bounded the problem, say, hey, this application can do these in number of things. Again, these things can run in a loop, but hopefully that makes sense. I just wanted to give y'all visibility of what actually works for people who have actually productionized. And so with that kind of being said, I'll just show a little bit of Phoenix. So once you get your traces in, I think one really cool thing is that, this is open source software. You can do pretty advanced things like you can filter and say, hey, show me where things have, hallucinated. You can grab specific points and then add them to data sets. And the whole point of adding things to data sets, so let's just say like, these are all the things that hallucinated, if I could spell. Right. I can save these data sets. Why do I want to save these like units of kind of traces off? When you think about how to fix a system, especially non-deterministic systems, you might have examples of things that went wrong. And even though if you've ever done a lot of prompt engineering and you've ever overtuned a prompt, where you go to fix one thing, but you end up breaking 2 other things, this is how you figure out if these things indeed, like if the fix you made is indeed going to fix the problem that you kind of want. So what you can do is, you can take some of the examples that we kind of put in here. I don't know why there's not any in there. Let me come back over here. You can take some of those examples of like traces that we had and actually experiment on them. So for instance, if you caught like examples of, hey, this semantic topic kind of hallucinated, and we see that kind of in our evals, you can then test across maybe those 20 examples to say, hey, if I change the model or the prompt or the way I orchestrated, did I hit 15 out of the 20, or did I hit 18 out of the 20? But the whole idea is that when you're experimenting, generally you want to keep one thing stable while you're experimenting with like another variable. So just wanted to quickly show that. Also, if you're working very deeply in the embedding space, visually this is very sexy, but it's actually not that complex. If you've never visualized your embeddings or you're working with a vector store, just know that using a UMap where you can understand and select areas inside of a semantic space, super useful in understanding, hey, do I have gaps in my vector database? Or if I want to project other pieces of information in this space, like let's call them LM as a judge evals. I can project, where I got, things that were, graded as relevant or irrelevant, kind of in this space. So wanted to quickly show you that. We do have some great open source tooling, and we always love to give back to the community. But if you have any questions, feel free to grab me after this chat. Happy to go very deep with folks. And if you want, you can scan this QR code. Again, Arise Phoenix is completely free, completely open source. There's nothing unlocked. You don't have to unlock anything. It's just free. Any questions?
Yeah, let's go to the questions. Okay, right up front. I'm going to try to stand between you and the speaker so we don't have feedback.
Thank God. So you talked a little bit about LLM as a judge, which I love. But when we start to look at bias towards judging models, when you're judging with the same model, we've seen some of that intrinsic behavior start to prove or start to mark things that are genuinely incorrect as correct, especially when it's not factual driven, but rather behavioral experience driven. How do you see that changing over time, or how have you seen that in the company so far?
That's a great question. So I guess the question is, like, when you're using LM as a judge, can you use the same model, and are there repercussions of using the same model, and what do other teams do? There's one really good slide I really like. Let me ask the audience a question. So let me tell you why LM as a judge, they make good indicators, and then we can go into the bias question. If I asked you, hey, audience member, can you summarize me something long and complex, like the book War and Peace? Think about that cognitive work versus I'm saying, hey, audience member, here is a summary of War and Peace. Is it a good one or a bad one? Cognitively, which one's harder, right? The first one. And so when a lot of, I guess, customers ask, can I use the same model? Well, the cool thing is that, like, you can use a different model. You absolutely can. We have a research arm that kind of does a lot of this, but we actually tested different models on different eval benchmarks on different public data sets. And it's absolutely true. Different models perform differently on different data sets. Makes sense? And stronger models can obviously perform better when it's a more advanced task, but that doesn't necessarily mean you have to use a bigger model. And so when it comes down to bias, the way I think about it is, yes, some models are biased in terms of, like, maybe they produce more output tokens, things like that. I think one pro tip we kind of teach our customers is, if you are running an LLM as a judge, let me come back here real quick. You can do this thing, it's kind of a trick. It makes you debug about 10 times faster. But let's say, for instance, we did have, for instance, a trace, and we got the label that it hallucinated, right? Well, what do you do as a human naturally in your workflow? Well, you're going to read one piece of text, read another piece of text, and then try to discern. You can actually automate that out. If you run the explanation and you say, hey, can you tell me why you did this before you give me the label? You'll get something like this, and it'll say, hey, blah, 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 blah. The answer is not based in the reference text and assumes information that's not available in what I injected. And the really cool thing is you can get a sense of that bias if there is indeed, like, that type of bias. But I think models are maybe more like input-output token bias and some other kind of more nuanced things. But if you're actually trying to figure out the why, again, you should automate that. This has helped our teams debug 10 times faster, and then you can make a lot of those other teams debug a lot faster. But great question.
Hi, Nico here. I just want to build upon that. So I run an evals company. I focus on AI safety and not only on observability. So indeed, what we call the LLM judge or LLM evaluators function is already central to most of the use cases being deployed here in so-called internal knowledge management. As we move towards more agentic features, it's going to be even more central with the problems that we've discussed before. It seems that you have done some benchmarking work on the quality of the LLM judge or LLM evaluator function. Do you want to say a little bit more about that? And if there is any useful benchmark out there, the ones on Hugging Face are great, but that's essentially robust. And if you've seen anything being done on the robustness and safety of this judge function. One is observability, drift, bias, but its robustness and safety in terms of being abused is also useful. Anything to share on that?
Good question. Can I summarize to make sure I understood? The audio is a little crazy here, but you basically asked like, hey, what's the difference between maybe the metrics on Hugging Face and maybe these, and then more specifically in the fairness, bias, and drift kind of area?
Any good benchmarking of the LLM evaluator or judge function that you see, particularly on the safety and robustness? Not the drift, not the bias, though they are very important, of course.
Yeah, safety and bias. I actually have a presentation on this. That one's been very interesting. I think we're learning more from the space, but what I think is some people do fairness through unawareness, right? If I don't have access to that information, which I think is fair in the LLM world. In the classic ML world, you could actually feature engineer some things like race or zip code, like socioeconomic status. But some folks, and I don't know the answer to that fully, but some folks do fairness through unawareness. So they'll do things like they'll search for any identifiers for protected classes, which turns out you can use an LLM or you can use like PII identifiers like Microsoft Presidio or Google DLP. But I think it's a good question. I don't know the answer to it, but there are some techniques, and it's like fairness through unawareness. And then you run post hoc studies. So some people they'll just like let their LLM application run as normal. And what they might do is, hey, if I have the demographic data later, then you might try to see, am I being fair and equitable to these different protected classes? If yes, then invest. If yes, then don't do anything. If no, investigate. So that's how we've seen it done in the past, but maybe there's something to that effect. It's a good question.
Raise your hand if you have a question. And if not, we're already out of time, but it was so engaging, I wasn't going to interrupt the questions and answers. So Dat, thank you very much. Warm thanks to Dat.
Thanks, Stephen.
And next up, we have Ofer from Victara.
Okay, so I just wanted to talk a little bit about RAG and Agentic RAG today. A little bit about me. I'm from Victara. We're a company headquartered here in Silicon Valley. You can see a little bit about us here, and I'll share the slides later. What we do is we are a Gen AI platform, so I'll explain what that is. Before that, a little bit about me. I had developer relations for us. I've been working in machine learning and data science for many years, and I got fortunate enough actually to get introduced to LLMs quite early, so I used GPT-2 when it just came out. So it's been interesting to see the progression, and if you want some interesting stories, catch me after that at our booth, and I'll be happy to share. So what is RAG? Most of you know this, but just kind of like my sort of overview of this is, and for some of you who may not know, is when you use an LLM directly with a user query to an LLM, you get a response. With RAG, the main idea is that you have another data set you pointed at. It could be your personal data or private data of the company or whatever it is. And when a user runs a query, you retrieve the most relevant facts out of that data set. It could be hundreds of thousands of documents, but you get the most relevant pieces of text. And you essentially ask the LLM, please answer this query given or grounded in the information that I just provided. So it's kind of LLM with your own data. It helps significantly in reducing hallucinations because you tell it which information to use. And it's not fine-tuning or training. There's no GPU required for the most part, and your data remains private. It's not trained on anywhere. So that's why enterprises like this quite a bit. And it also allows you to show citations and provide explainability, which I'll show you in a demo in just a minute. So how does it work a little bit more for the developer-focused folks? How does it look inside, right? So there's two flows in RAG. You ingest the data in, and then what happens is you take the data, you sometimes extract the text from it, if it's a PDF file, for example. You do something called chunking, which breaks it into different pieces. You run an embedding model to create a vector embedding of each chunk, and you put it in something called a vector store. You actually also put the text here somewhere, but I didn't put it in the slide to simplify. And then when a query comes in, you get the query, you embed the query as well, you run it against the vector database, get those facts I talked about earlier, sometimes run it through a re-ranker to provide even more relevance. You get a prompt to do exactly what I said, which is, hey, given these facts, please summarize or respond to this query. You send it to the LLM and you get the response back, okay? And one way I like to explain about Vectara is we're RAG as a service, which means you can build this yourself, either from scratch or using LangChain or Llama Index or the 15 other orchestration frameworks out there. With Vectara, we put all of this complexity of infrastructure in a box, so to speak. So all you do is you index the documents or the text here, and you run the query through our API, and all the complications of managing this infrastructure, which, by the way, is easy if you do it on your laptop. When you go to enterprise scale, it becomes complicated doing security, doing privacy, making sure everything is up and running. So that's really what Vectara does. Now, in terms of use cases, we have a little bit of a terminology that's interesting about differentiating between assistants and agents. Excuse me. We think of assistants as the type of software systems that respond to user queries. So it'll be chatbots and question answering and things like this. Whereas agents are things that actually take action on your behalf, right? They will book a flight or they'll send an email. So we see the difference in enterprise adoption in terms of level of risk. Assistants are just, you get a wrong response, it's sometimes okay, but if you actually take action and action is wrong, it's just a higher level of risk. Now there was talk about hallucinations here, and Dat mentioned it too. This is one of my recent favorite examples, and I keep finding more and more as the LLMs fix them over time. Raise of hand, whoever saw this TV show called Lovejoy? It's very rare. It's a British show. My wife seems to have found it and liked it, so I've been seeing it with her a little bit. There's a character named Lovejoy there, and it's like 6 seasons, Lovejoy. So I've asked Anthropic, what's the first name of Lovejoy? And the answer was Ian, and that's wrong. Right? Ian is the name of the actor, not the character. And in fact, there's no first name. Like it doesn't exist. It's throughout the 6 seasons. So that's a show. But there's a lot of other examples. And I'm mentioning this because too, Dat mentioned LLM as a judge to detect hallucinations. I wanted to introduce all of you also to something we developed, open source to the community called HHEM. It's the Hallucination Evaluation Model. And you can find it here. It's on Hugging Face. There's a leaderboard that's shown here. And what this does is it's another way to test whether a set of context and a response is a hallucination. And the nice thing about HHEM, which, where's that? Are you here still? Did he go? Which is also going to be integrated in the Rise Phoenix pretty soon as an alternative. But what this does is it allows you to, it's just a model. It's not using LLM. So it's cheaper, it's faster. I mean, LLM as a judge could take 3 or 4 seconds. And it's also more reliable because what happens with the LLMs is you use this LLM and then OpenAI changes it to, shifts it a little bit. And so you can find it one time you run it and it says it's a hallucination. The other time it says it's not a hallucination. So it's a little bit difficult to rely on in some cases. So check it out if you're interested in hallucinations more. This is open source. You can use it when you're building RAG. So, okay, so I want to go to agents quickly. I just want to give you all this intro. This is one of the pure RAG demos that I wanted to show. I'll make it a little bigger. We'll call it Ask News. Again, we ingest all this data from news sources, and just to show you what I mean by citations, when you ask a question, a query goes to Victara. This is just a UI that we made open source as reference, as an example. And you can see you get not only the answer, but you get these citations. If you click on one of these, you see where the response was from. You can click on this link and verify it. So this ability to give an answer along with the references actually increases a lot of trust in RAG in general. And also this is the HHEM score, so we return that from our platform directly so you can see whether this response is hallucinated or not, or suspected to be. Okay, oops, I didn't want to click that. Okay, so agents. So we're here for agents, and I'll tell you a little bit more my perspective too, but generally this is a very small diagram to show how it works. You got this agent in the middle. It's an LLM that does reasoning and planning and takes advantage of tool use. And in our focus of agentic RAG, this is a name that's been used in the community for this, you can give the agent different tools that are just real-time REST API tools or whatever, but you can also give it RAG tools. And so we recently launched this, oops, did I go the wrong way? Victara Agentic, which makes it easy to use along with Victara. It's based on good work done by Llama Index, so shout out to these guys. But essentially you pip install Victara Agentic. And this is the most simple way to use Victara Agentic. It's just wrap your RAG tool with an agent. Even that is actually useful. And so you define a corpus of data, you send the data in, you have it in Victara. You can use the regular RAG, but you can also wrap it here and say the data is in medical data, benefits, Medicare, etc. You give it some information, and then you can just ask it question, and it will do better than the regular RAG in some cases. For example, it might rephrase your question. It might decide different things to how to use this tool in a best way. And I'll show you a demo of that in a minute. But of course, Victara Agentic has other capabilities. You can build a full-blown agents with it, define multiple tools. So I encourage you to go to the documentation and see how to use that. But it's meant to be really easy and simple. So let me show you this demo built with Victara Agentic, and yesterday Hugging Face was out, so hopefully today it's okay. Okay, it's okay. All right, perfect. So this is a demo. We took all of the case law in the state of Alaska and plugged it into Victara, so it's a pretty massive data set, and gave it a bunch of tools. This is for legal, so it's got one tool that calls this corpus to answer a question, but also other tools like summarize a case or give me critique as a judge. You can define all kinds of interesting tools. So for example, if I go and do this, what happens now is the tool is deciding what to do, calling the different tools, and once it's finished, I'll show you what happened. But you see, it gives you this response, and if we show the logs, you see that it decided to call the RAG tool here with this query, which is, I think, a little bit different than the original. So see, it kind of decided to remove the what if and call the tool. It got the response, and it presented it back to me. So now what I could do is I could say, okay, there's a couple of things here. Maybe I'll do, please summarize Brigman versus State, for example. So now, hopefully, if the demo gods are with me, it'll identify this in here and know what I'm talking about. Go get the full case text and summarize it. And this is kind of what it did. It went to the opinion text tool that I provided to it, and it pulled up the right citation. You can see it actually knew from here that this is the citation number which the tool required. And it asked to summarize equals true. And so the tool went, pulled everything, summarized, and responded back. So very, very powerful stuff. You can build, literally I built this demo in a couple hours. It's really easy to do. And that's it. Thank you very much. I have a couple more. Thank you.
Thank you, Ofer. We're going to go to some Q&A.
Just one thing I wanted to mention before we do that. I put a little plug in for here. This is not something that we do or get any direct benefit of, but I partner with Deep Learning AI, was mentioned here earlier. If you're interested in learning about embedding models, we created a class pretty recently, and a lot of people like it because it's an area that's not been taught. There's 15 classes on RAG, on deep learning AI. I think there's one on embedding models. So if you're interested, check it out. Sorry, go ahead, Stephen.
Oh, this is still all you, all Vectera, and thank you so much for being one of the sponsors of not only this event, but the last couple days, the very active hackathon we had. But let's go right to questions. Anybody?
You mentioned that it helps get the product into enterprise, and I'm sort of interested around what you mentioned, particularly around security. So let's say I have financial and legal data that only the C-suite is supposed to see. How are you ensuring that my intern is not retrieving that sensitive information?
Very, very good question. So, so this is actually something that RAG does pretty well. So usually what you do is when you index the data, let's say there's data from the CEO or the HR department, things that are more confidential, you add metadata to them that's mentioned here, and you say, you have to figure out the scheme for that. But then when you retrieve the data in the query flow, you can filter by who the user is and only make sure that the facts that are being shown to the LM are only the ones that the end user is able to see. Great question. Other questions?
I saw some other hands. I see them going up. Hesitation right there.
So, can you also send the documents through the API, or is that in the interface basically that you need to do that?
You mean through here?
Like, how long does it take for it to basically embed and then be ready to call? Like, can I do it on the fly? Like, a user uploads something in my interface, and then how quickly can I call your service?
So about 1.5 years ago, we released a feature called instant indexing. So it takes about a second. It's instantly available, probably even less. I don't want to disappoint you, so I'm saying a second. It was probably less than that.
Great pitch, thanks. I was want to follow up on that gentleman's question. So you classify or mark the data, or you kind of like give the authorizations to the users, like which side you kind of like, I don't know if I make it clear.
Say it again, ask again,
yeah,
please.
I was wondering, you mark the data, or you give the kind of like a rights to the person who can retrieve the data to...
No, so we mark the data coming in, and when you run the query API, when you implement, this is something that you implement on your own as a developer in your organization, you will need to send out the filter to make sure that the query API filters documents that are not appropriate for this person to see if it's not the CEO, let's say, or somebody else, right?
I see. Thank you.
Okay, one more question. Here we go.
Thank you. So I was curious about the model you're using for the embeddings generation. Like, is it something on your own?
Can you speak closer to the mic? I'm sorry, I'm hearing.
Yeah. What kind of model are you using for embeddings generation? Like, is it something on your own or OpenAI model or something like that?
So because we are kind of RAG as a service, we want to make sure that all the components are ready-made for you. You don't have to worry about it. You don't have to choose which one. They're just really, really good components. So our embedding model is called Boomerang. It's our own. It's actually kind of competitive with OpenAI and Cohere for English and much better in other languages. And similarly here for the LM, all the components we make sure that they're just good for you and you don't have to try 50 embedding models and figure out which one is better. That's one of the challenges I see in RAG, and people having so many options and they don't know how to like run a huge experiment to figure out what to do. So we try to there's less optionality, there's less flexibility in this model, but it, 95% of the case will work right out of the box, and we have a lot of optionality to choose where it matters for you. Okay. And yeah, we have, if you have any questions, maybe you can, we have a little booth over there. We might have some shirts also left over if you're interested, so, all right?
Very cool. Thank you, Ofer.
Thank you.
All right, good afternoon, everyone. Just real quick, so
I'm Brian Wong. I'm a partner with a firm called Moss Adams. I'm actually joined here by my colleague, Brittany, who's standing over there at a Moss Adams signage. So we are a full-service CPA and accounting firm. Both of us are actually very interested in the AI space, and that's why we're here learning about AI and being amongst all of you here today. But a little bit about our firm. So again, we're a full-service CPA firm. We work with startups all the way to publicly traded companies and everything in between. For a number of our startup companies, we actually do everything from the bookkeeping to accounting software implementation to tax compliance and tax planning. We actually work with a number of very early stage startups monetize for their first time, credits and incentives. We also work with their founders so that they can start tax planning today for potential future tax gains in the future. As companies grow, we grow with them. So when you start commercializing or doing business in additional states, going abroad, we will continue to work with you. And as you either go through M&A deals or you go public and you're a publicly registered company, we continue to work with you. So that all to be said that, hey, when we work with you every single step of the way, so you don't have to keep changing your CPA providers. We're not AI agents, but we are people that can help you. So Moss Adams here in California, we're actually the 5th largest firm. We have a team of almost 5,000 across the states here, and we work with companies who may have activities in 120 plus different countries. So if you guys are interested in chatting, please feel free to reach out to Brittany or myself. We're going to be back there. We're going to have some drink tickets apparently, so it might be popular for a little bit until we run out. Thank you all so much, and thank you, Steve, for giving us the opportunity to chat here.
Oh, you guys are on.
Hello,
should we do it like we did it last time? Okay, 2.5 minutes on the clock.
2.5 minutes, got it.
No, you got a few more.
Oh, okay.
10 minutes.
Oh, okay. Yeah. So recruiters face a lot of competition when looking for top quality candidates. They look on LinkedIn, referrals, funnels, all kinds of other sources. And one kind of untapped potential is GitHub repos, the actual quality of the coders they're looking for, because they, especially for the smaller startups, are looking for people who have a specific kind of specialty. And so just like Moneyball uses statistical analysis to find underrated baseball players, Moneyballer wants to go to the GitHub repos to find these undervalued developers that are especially tailored for recruiter roles. So here's how it works. Step 1, we scrape their GitHub repos to get the commits, the repositories. Step 2, we have multiple agents that evaluate the code from a business perspective, for example, the CEOs, a architectural perspective, for example, CTOs, engineers who look at the READMEs, who look at the PR descriptions, who look at the issues, the code reviews, and so forth. And then step 3 is actually judging the quality of the code in terms of the class structure, the functions, and with Python, the PEP8 style guide, for example. And from this, creating a report for the recruiters so that given a JD of a candidate, they can get a nice summary out of the top candidates, as well as an analysis of their coding styles.
Yeah, and let's jump to a real demo. So imagine a scenario where you're a recruiter and you're looking for full stack developers from university campuses. You would just enter this query and we would be searching for developers through their GitHub profile. We do a scrape over GitHub for specific repositories that signal for top quality developer talent that might not be obvious to a recruiter. So some things might be specific signals, like they forked the transformers library and made a couple changes to specific files, and you're able to find their GitHub profile and get their LinkedIns and follow up with them. And yeah, we can talk more in depth about the algorithm.
Yeah, so Moneyballer really, as a product, it's a platform which allows these undervalued developers to really shine because these signals aren't shown elsewhere. And so how it works is that a recruiter or someone seeds in some good repositories, some representative repositories that they might have wanted them experience in. For example, someone with experience contributing to the PyTorch, Llama Meta, and so forth. And given these repositories, we scrape the top contributors from them, and we look at the contributors' repositories as well as the contributors' commits on the repository you're first referencing. And for these repositories and for these commits, we are going to identify their code and evaluate the quality of their diffs and use all of this to generate a summary of the quality of the repos, the quality of the commits, and an overall quality score of the developer.
Yeah, and before, we were creating a more generalized version of this called Super Connector. And we actually created a Super Connector network for this event. So if you go to, let me find the QR code. The top right. Oh, found it. Yep. You can try scanning this QR code right now. And once you're in this ai.superconnector.network, you can do similar searches for people within this superconnector network. And you can find people of similar interests. And we do a very similar approach where everyone has their profile uploaded and they can find each other on this connector network. So let's do a quick demo. And I'll leave this up and come reach out to us if you have any questions. So let's say I'm looking for developers with full stack experience. And I send. It's going to take a couple seconds. And there you go. We have a couple of candidates within this superconnector network that we can request an intro for.
And these are the people who've opted into the network so far. And so throughout the course of the event, there's going to be more and more people here who could get recommended for you. So check back in again tomorrow, and you'll see even more people.
Yeah, there we go. And I'll leave this up here.
Hey, we got questions. Let me run the mic because otherwise people making all the noise in the back won't hear.
Hi, thank you so much for the intro. I have a question regarding the problem space you are trying to solve. Are you trying to disrupting current recruiting process by providing this solution? Obviously, a lot of FAANG company currently still using very traditional technical without any AI adoption. So I want to get more clarity on that. Thank you.
So to start, this is just one additional channel for sources to find candidates. Currently, there's like a bunch of different channels like LinkedIn, resumes, career fairs, and so forth. And we see this as a really under-tapped pool, and especially for people who are looking for niche kind of open source contributors.
More questions?
So a cool product. Is this primarily for like people who are looking? Is this primarily for people who are looking to hire engineers, or can engineers also like find cool opportunities that like interlay with their experience?
Yeah, so right now it's people looking for engineers, and in the future we can see this evolving in having a community of developers, because we're going to have more and more developers who've been kind of their code analyzed, and so we can even maybe have some kind of best practices, like a scoring system where, okay, these are the top quality people, and we can also have their feedback, like refine this algorithm. So we can see a lot of potential for building community as well.
I think there's one more question over here. Raise your hands if you have questions. You have a question.
Yes, I do. Well, Eden, what is the most, what's an example of a kind of information that if you scanned, if you put it in at this event, it might help you meet people you'd want to meet before the night is over?
Could you repeat that question for the audience?
I have a follow-up question. Yeah. Why are you pointing a light in our eyes?
Yeah, what's an example of a question or a comment that you could put, that someone here, if they wanted to meet interesting people before this event is over, could put into the system after they scan the QR code?
Oh, what's a comment? Oh, of course.
Yeah.
Yeah, the more information, the better. You want to put some, your background, your interests, and the kind of people you're looking for.
Should we try it live?
Yeah, so over here, I've already put in my bio before, but if you scan the code, you'll be prompted to put your own bio. So in this case, I was super interested in computer vision and music, and I was looking for fellow Canadians within my network. Currently, I'm only searching within the AIFI, but I can also connect to the public network, which has over 1,000 people who've already signed up and have tested it. So you can find people within that, within SF, within other networks that you're part of. And yeah, do we have any sample question or queries?
Well, I think that's good. It answers my question. And then I guess the follow-up question to that is, when will you have this on Product Hunt so we can get that 1,000 up to gazillions?
Great question.
You don't have to answer.
Yeah.
I'm sorry. Just people who know me, a lot of my questions are rhetorical.
Just a quick question. As AI creates more code, what attribute will attribute will be most important to figure out who the right developers are? Because as AI agents kind of create more code, it's pretty much going to be the same code for most of the engineers, right? So how do you differentiate good engineers from bad engineers or neutral engineers?
Okay, the question is, how can you differentiate the good engineers from the bad engineers who may have copied code?
Code as an AI agents creating more code, right? You have so many coding agents, so that's going to be created by agents or AI. So how do you differentiate good engineers from neutral engineers?
So this is tricky. We can't really tell the engineers themselves like what process they used. It's more of the output, and so yeah, this is tricky, but in the future we may consider using like some code similarity to see if they like blatantly plagiarized it. But like right now, if it's like the PRs are really good, the commits are really good, they follow good style, they're probably a good engineer.
Thank you.
Thank you.
Thank you, Moneyballer. Next up we have Sponsor Skip with Deepak.
Okay, hello everyone. Hope you all had a great lunch. Yeah, so I'll just explain what we built in the hackathon. So it's pretty straightforward. So we just met at the hackathon like on Saturday, and we formed a team and we built this whole thing. So it's basically what we are doing is we built a Chrome extension, so which basically skips your in-video sponsor ads, which means which are embedded within the YouTube video or any video for that matter. Yeah, so basically everyone who watches YouTube on their laptop probably can use this. And yeah, the main thing is we use AI to basically identify the sponsors within the ads. So we use a couple of two-time modeling. So what we provide is basically seamless viewing and sponsor skip. It's an AI tool. So these are the key features. Basically, users are happy. They would be willing to definitely use it, and seamless experience for that. And we also identify which sponsors with which ads, so good data, so some AI innovation there. Yeah, so basically business model, I think we will probably do like other ad, ad blocker, etc. So freemium model, everyone can use, that will always be there. Premium, we can do a lot of ad personalization also. Like some people are okay with some kind of ads while they don't want to see some other ads, and even content, slowly we can even trim down across. Like one video can have a lot of different kinds of content. Maybe I don't want to hear bad news, so I'll just probably filter that out too. So, and also multi-platform support. I think those are the major ones, so that even on your phone, everything's there. So there are also some, enterprise offerings. So this was the team. So two of them were on Discord, but yeah, we built it. So I'll just show you the demo, I guess. Yeah.
It takes the time squads and then skips the video. So we're going to reload this real quick.
Okay. Okay, you guys can't hear the audio, right? Okay.
And essentially how it works is that
Yeah, so basically this is the working demo.
skips the video. So we're going to reload this real quick.
Good month, eh? Right? I haven't charged my laptop in days. Couldn't care less. I didn't charge mine for free and get one entry per dollar spent using the link in the description.
I'm going to get up with you. Okay, if you need another mic.
No problem. Yeah, so basically that was the demo. I don't know if you could see, I'll just show again.
And
I know it's a little tricky.
It takes the time squads and then skips the video. So we're going to reload this real quick.
Good month, eh?
So if you see around 007 it starts and it just skips to 45 directly.
I didn't charge mine for free and get one entry per dollar spent using the link.
And essentially how it works is that it takes the time squads.
Yeah, so I think that's the demo. So essentially how it works, so if you see, it didn't cut the entire ad clearly, so you can still see he was talking about some sponsorship like something, but yeah. So majority of it, what we did was we used all this Fetch.ai, we have used Prem and Grok to test out different models. So we basically wanted to identify the best model which can do this, to identify the exact sponsors if it is there, and then identify the exact timestamps from where the sponsor is. So I think the best way would be to actually have a custom model, so because it's a very straightforward application. So just with general model we could achieve this, so I think with the custom model it will be much better. So yeah, I think that's it for the demo. Anything else you guys wanna? So I'm just here if you wanna chat. Always welcome. Yeah.
And if you want to ask questions, we have a hand up. I have a mouthful of bagel, so you go to use talking.
Can you build this for Facebook?
Yeah.
Is that a one-word answer? Did I hear yes?
Yeah, I think so.
Okay. Do you want to talk any more about that?
No, I didn't get the question, sorry.
Oh, can you build this for Facebook?
Yeah, everything. You just have to go there, Chrome extension install, done. All your videos, everything, we just cut it off. Anything there's a sponsor brought to you by anything. And we can modify it to literally anything. Yeah. Yeah?
Where can I install it?
Oh, okay. Yeah, I'll let you know once we are live. I'm really sorry for this. Yeah.
But it will be in the Google extension library, I guess, at some point.
Yeah. Or I'll just share with everyone. Yeah, I'll let you.
Yeah, he's gonna steal the list for the event and send it to
I'll connect with you definitely because you are a customer. So, yeah, of course.
Okay, more questions.
So, no, what's the difference between freemium and premium? Like, what are the benefits in premium?
Oh, of premium? Yeah. Yeah, so with premium, so the main thing is ad personalization. So suppose you can now choose what kind of content you want to filter. Like I'll give you one example. So YouTube, what happens is some of my friends also complain is that after a point, it's the algorithm recommending you like a lot of stuff, and you probably have to query everything which you want. So what you can do with this, let's say I'll give you an example. You just say I'm in the mood for happy songs or something. Just select some buttons like happy, sad, or anything, and all the content can actually be just filtered right out from all the videos. So that is one example. And even ads, if you say I want food ads are okay because I like food, so I'll order. So you just save these categories.
So the basic point of this particular model is to remove all the advertisements and again we are giving them options to look at a few advertisements.
Yes.
Okay.
Yes.
Then, okay.
We will sell ad. Yeah.
Understood.
I understand. Yeah.
Understood.
It's basically an AI agent, so you can literally make it do what you want to do once you are. Yeah.
And as a testament not only to your own skills but to AI, how many people worked on this project and for how long?
No, so I just met all of these five. Like this was the team. So I met at the hackathon, all of them. Max and Joseph worked very closely. We met at the hackathon only. It was actually Max's idea. So, but yeah, Joseph was pretty interested. They also pitched. We actually formed the team together. Everyone pitches their idea, and I was like a solo developer. I just came from India like 2 weeks ago. So I was at these events just exploring. So yeah, I met these great guys. And the talent here is amazing. Like seriously, I have been to events. Like I've been to events in Bangalore as well. I have been here also. So the talent is amazing. We built this just like 24 hours, I guess. Yeah, great product. It's working. Yeah, seriously.
So when is it going to be on Product Hunt?
Yeah.
When is it going to be on Product Hunt? No, I'm just joking.
Yeah. No, we will do this, I think, this week probably, yeah. Once I think this event is over, that's what we are doing. I have told already my team also, they're working on Discord, yeah. We are good.
Fantastic. Okay, thank you, Deepak.
Yeah, thanks a lot for the platform, yeah, thank you. Thanks everyone for listening.
Items are traded on the second-hand marketplaces in 2024, but this number is estimated to grow to 125 billion in the year of 2034, which is a huge increase, almost 3x. What are some broader applications of this project? We can apply this negotiation agent in the terms of real estate. It can help you find a better rental deal, better housing in case you're buying a house. It can help you negotiate a better house deal. Automotive, in case you're buying a car or even getting driver's insurance, try and negotiate a better deal for you. Also for your health insurance. So you guys can scan this QR code to sign up for beta testing in case you guys are interested. All right, I don't know when to switch to the next slide. So, good? Okay. And this is my team. I've got 2 other members in my team. I'm the CTO. I've got a CEO. His name is David. He's based out of Vancouver. And we've got our product manager, Kareem. So Kareem brought a lot of experience in Facebook Marketplace because he does a lot of buying and reselling on Facebook Marketplace for bikes. So we got a lot of insight on both sides. And David has built a lot of full stack products, and he's transitioning between startups right now. And these QR codes are for our LinkedIn pages in case anybody wants to get in touch. So that's about it. Any questions? Yeah.
Here, let me get you a mic.
Thanks. Can you share the beta QR code again?
Yeah, sure.
Thanks.
Yeah.
Any other questions? You don't get an extra drink ticket just for a question. Okay, only for sitting here.
No, it's okay. Can I fine tune this on my negotiation style?
Yeah, so that is one thing that we've been working on for actually with Prem AI. So we're going to be selecting some of the good, we're going to be running it multiple times and finding out good negotiation prompts, the responses, and use that to fine-tune our model. We haven't decided which model yet. We currently used Llama and I think Mistral We haven't done a comparison yet because we only had 24 hours, but we're going to be fine-tuning that based on our negotiation to better our negotiation responses.
Can I give you a recommendation?
Sure.
If you use Langsmith, they've been doing some work with DSPy.
Can you speak a bit louder?
Sure. So Langsmith's been doing some work with DSPy for prompt tuning, and they have human-in-the-loop feedback systems that you can use for exactly fine-tuning actively. So you can go and use their dataset functionality. It's really cool.
Awesome. Thanks. I'll definitely look into that.
Sure. No worries.
Oh, we have more questions? Yes?
Hi, so I'm Maria. Very impressive for 16 hours or 20 hours worth of pulling this together. I'm very curious.
Okay.
Why this specific area that you're interested in? I mean, is this something all of you are passionate about?
Yeah. So we're kind of passionate about this because we see like negotiation is a skill. It's like a human skill, and I feel like there are a lot of opportunities where you could negotiate in a lot of instances, but people, they tend to be timid or shy and they don't really go out there and negotiate with people. So if you offload that onto an AI agent that does that for you, I think it has like a huge scope.
And how are you guys planning to make money?
Oh, so currently, because it's an AI agent, so it's pretty kind of cheap. All that we have to pay for are the prompts. So we're thinking on probably like a freemium model where we allow users to try it out for like 5 or 10 negotiations, after which we have a price plan where you pay for credits and you can have that many negotiation chats.
So like when I was a student, like finding housing was like a big challenge sometimes. So can this be applied to like finding lease agreements that are like housing listings?
Yep. That's another thing that like I mentioned over here for real estate, for like buying a house and renting out a place. So we can help you negotiate a better deal.
That's awesome.
Any plans to negotiating the other way, like if you're a seller?
Yeah, so we have thought about, creating like a negotiator on the buyer side. And then we thought that, if you have an agent for the buyer and the seller, like it would just be like a cat and mouse loop. And it'll just like keep on going until they finally converge at some point, which would be really interesting to see actually. Yeah.
What is the convergence point? Like when do you have the agent stop negotiating? Because I mean, I guess it could keep pushing forever.
Yeah, so earlier, like when we first started working on it, our agent was really aggressive. Like the seller would be like, 180 is my last offer. And the agent would be like, I have got confidence in you. I'm sure you can go below 180. Why don't you try 150, So
that's the tactic I use.
Yeah. So we kind of had to prompt engineer to tell it to, like once the seller is kind of like, doing some like natural language processing and like see like once the seller is not responding, that's probably like the last price.
Do you have any data on if the more aggressive approaches worked?
What?
Do you have any more data on if the aggressive approaches worked comparatively to the...
We didn't get a chance to test it out because this was all done in a span of 24 hours. And we're limited by the seller's response because the seller is not going to give us an instant response, right?
Let me know if you get some data.
Huh?
Let me know if you get some data.
Sure.
Do you have the seller side agent as well?
No, not yet.
Okay, but obviously you're going to build that because...
Yeah.
Okay.
Most likely.
Great. Any more questions? Otherwise, we only have drinks left. Okay, thank you, Sanjeep Day.
Thank you so much.